Hey guys, tonight we're going to drift through the softest mystery in all of science, why the universe keeps expanding and why that's oddly comforting. Imagine lying on your back beneath a sky so wide it has no edge, the stars frozen in their endless retreat. You're about to float among them, weightless, watching creation itself take one slow breath after another. And here's your tiny existential plot twist you're expanding to just a little. Every atom, every cell taking part in the world's quiet stretching. You probably won't survive this cosmic scale of calm, that is. So before we continue, hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching, from what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You exhale and the air in your room feels like it moves in sympathy with something bigger. Astronomers say that space itself is doing something similar. It's expanding not because of an explosion, but because the fabric of reality is still relaxing from the first moment of everything. The galaxies aren't racing away through space. The space between them is stretching like warm taffy. If you could mark 2 points on that invisible fabric, a distant cluster, and your own home galaxy, they'd move apart without either of them actually travelling anywhere. They're just passengers on an inflating carpet. It's easy to imagine this expansion as loud or dramatic, but it's the opposite. It's slow, nearly imperceptible, like the spreading of a shadow over a mountainside at dusk. Even the fastest galaxies shooting away at a quarter of the speed of light are doing it in total silence. The only noise is the whisper of background radiation, a kind of cosmic afterglow, so faint that it hums at microwave frequencies most people's kitchen Wi-Fi could drown out. Scientists still argue whether this process will ever stop, but for now, it continues like a pulse that never loses rhythm. There's something serene about that certainty. Every second, billions of light years of empty space get just a little emptier, yet the pattern stays gentle and symmetrical. It's the ultimate slow dance one that's been going on for 13.8 billion years. When you think of the universe expanding, you might picture stars being flung into some great void, but that's not what's happening. It's not matter exploding into space, it's space itself creating more space. And you're part of that, sitting there with gravity pressing you softly against the Earth, while atoms beneath your skin hold hands so tightly that they ignore the universe's polite invitation to drift apart. Your coffee mug doesn't grow larger, your bed doesn't stretch, because local forces, electromagnetism, gravity keep everything cozy and compact. You can thank those for the fact that your blanket won't slowly turn into a parachute overnight. Still, there's an odd thought that slips in when you remember all this. If the galaxies are drifting apart, there must have been a time when everything was impossibly close, too hot, too dense, too bright. In that ancient moment before the first atoms existed, the universe wasn't a stage for stars. It was a single glowing note ringing out into what would become infinity. Some scientists like to call it the cosmic breath. You might prefer to think of it as the first sigh after an unimaginable heartbeat. Even now, that echo moves through every cubic centimetre of the cosmos. It's stretched so thin by time that it chills at just 2.7 Kelvin, a temperature barely above absolute zero. And yet, that background warmth touches you right now, softly and visibly, a relic of when everything that would ever be was once smaller than a grain of sand. Astronomers can measure this faint heat like detectives tracing fingerprints, and when they map it, they find subtle ripples, slight differences in temperature 1 part in 100,000. Those ripples are the ancestors of everything, familiar galaxies, stars, oceans, and you. Without those tiny imperfections, the universe would have remained an even endless mist too symmetrical for anything interesting to happen. So if perfection ever sounds appealing, remember it's the flaws that make worlds. Every second, the expansion continues steady and reliable. Galaxies slide away from each other, not in panic, but in an ancient rhythm. If you could see the universe on a time-lapse, it would look like glowing embers drifting apart in slow motion. Somewhere in that drift, our own galaxy spins, trailing a faint spiral of memory. Light from distant realms keeps arriving, stretched into longer and redder waves until it fades into invisibility. The farther it travels, the more it yawns, like it's getting sleepier too. Scientists still debate whether this expansion will last forever, or eventually reverse. Maybe someday gravity will call everything home again, maybe not. But tonight the numbers say the pace is quickening, not slowing. It's as if the cosmos, after holding its breath for eons, decided to relax even more deeply. So you lie there, the ceiling above you pretending to be a sky, the hum of your fan pretending to be the cosmic microwave background, and you realize everything that has ever existed is part of one long exhale. Galaxies drift apart, atoms hum in quiet defiance, and time itself stretches between them like a silk thread in the dark. The most relaxing fact of all is that none of it asks for your permission. It just happens endlessly, effortlessly, beautifully. Somewhere a photon that began its journey when dinosaurs roamed the Earth is still traveling toward your eyes, lengthening with every moment, a reminder that even light gets tired. But it never stops, and neither does the expansion that carries it. The universe is breathing, and tonight so are you. You float on your mattress, feeling the faint weight of gravity pulling you toward the center of the Earth, while something far larger and quieter stretches everything around you. You don't feel it, not even a tingle. The walls aren't inching apart, your cat isn't drifting toward the window, and your phone charger isn't getting any longer. Yet space itself, the invisible grid that defines distance, is expanding through you right now. You're part of a universe that is literally growing between heartbeats. It's one of those cosmic paradoxes that scientists like to whisper about in late-night observatories. Space is expanding everywhere, but not in ways you can personally notice. Why? Because the forces that hold matter together are incredibly stubborn. Inside you, the electromagnetic fields binding electrons to nuclei are many trillions of times stronger than the faint outward stretch of cosmic expansion. The same goes for the gravity that keeps the Earth's oceans clinging to its crust and the solar system orbiting the sun. So while galaxies billions of light years away are sliding apart faster than sound, the atoms in your coffee cup are practically shouting, "We're not moving." It's like sitting inside a calm little eddy while the great cosmic river flows silently past you. Scientists sometimes call this balanced cosmic decoupling, the idea that on small scales, gravity and electromagnetism win keeping things cozy, while the rest of space politely recedes. Imagine for a moment if it weren't so. Your morning routine would become surreal performance art toast, flying from the counter coffee mug, drifting toward the ceiling, the cat gently orbiting the couch. Thankfully, the forces of nature hold you together far more firmly than expansion can tear apart. Even galaxies are safe islands amid the tide. Still, this hidden movement is happening everywhere, like a deep, slow breath through the bones of existence. You can't feel it, but you can see it in the way light from distant galaxies is stretched and reddened. The farther away a galaxy is, the faster it seems to be retreating. This is what Edwin Hubble found in 1929. Every galaxy's light bore a redshift that increased with distance. It was as if the cosmos itself had turned into a conveyor belt that carried everything outward from everything else. And here's the mind-bending part: there's no central point of that motion. Every galaxy sees itself as the calm center of expansion, watching others drift away. If that sounds narcissistic, it's actually democratic. The universe expands evenly everywhere. There's no cosmic throne room, no edge, no special place where it all began. Scientists still argue whether our three-dimensional world is the surface of something larger, like the skin of an inflating balloon, but the evidence says no edge, no outside, just more. You might imagine that expansion would feel like acceleration, but it's smoother than that. It's not a wind blowing through space, it's the metric of space itself changing. You're not being pushed. The ruler you use to measure distance is slowly stretching. Somewhere, a photon that started toward us as billion years ago is still en route, its wavelength elongating until it slips from visible light to radio waves. It's like a traveler aging during the trip, arriving at our telescopes weary and red-faced. The strangest thing is how uniform it all is. Across hundreds of billions of light years, the same pattern holds. The expansion doesn't wobble or stall, it glides forward like a perfectly tuned hum. Some cosmologists call it the Hubble flow, and while the name sounds like a jazz band from the 1930s, it really means that on the grander scales, galaxies move apart in exact proportion to how far they are from one another. Double the distance, double the speed. There's comfort in that symmetry. You might feel small, but you're caught up in an exquisitely ordered drift, as if the entire universe were a single breath slowed down to near eternity. If you close your eyes, you can almost sense it, the faint idea of stars moving apart in silence. clusters spreading like seeds, every motion perfectly smooth. But beneath that calm, the math is wild. The universe isn't just expanding, it's accelerating. It's like watching a balloon not only inflate, but learn to inflate faster. The cause? Dark energy. The great unknown force that seems to make up about 70% of everything. Scientists still argue whether it's a true energy field, a property of empty space, or just something we invented to make equations stop crying. Whatever it is, it's real enough to make distant galaxies drift faster every second. If you could see that from outside, which of course you can't, it would look like a glittering cloud, slowly dilating in slow motion, every spark moving outward forever. And yet from your bed it's utterly imperceptible. That's the wonder you live inside an enormous expanding miracle that's also perfectly ordinary. There's an odd serenity in that realization. You're part of a process that doesn't care about stress deadlines or phone notifications. It just is. The same physics that guides a supercluster also guides your quiet breath. Expansion, resistance, balance, release. The same rhythm plays on every scale from galaxies to lungs. You roll onto your side, feeling the sheets pull gently, and you imagine the galaxies doing the same, curling away from one another in the darkness, carried by something invisible and ancient. You don't have to hold on. Nothing in the universe does. The beauty of cosmic expansion is that it happens even when no one's watching. It requires no maintenance, no intervention, no approval. It's the purest expression of peace, endless, effortless letting go. So while your atoms cling together, the universe around them quietly grows. The distance between the galaxies widens by millions of kilometers every minute, and you against all odds remain whole, safe and comfortably small. Somewhere out there a nebula exhales, a star dies, a black hole drifts and the silent pulse continues. You'll never feel it directly, but that's okay. You don't feel your own heartbeat every moment either. Some things are too constant, too gentle to notice, and maybe that's exactly why they matter. You wake, or maybe you drift in the dark between stars and a quiet thought arrives. Someone once looked through a telescope and realized that everything was moving away. That moment, almost a century ago, changed our understanding of existence forever. Edwin Hubble stood at Mount Wilson Observatory surrounded by chill mountain air and the low hum of machinery measuring the faint red fingerprints of galaxies. He expected to find order, maybe a gentle cosmic breeze. Instead, he discovered the universe sprinting outward in every direction. Until then, people thought the cosmos was static, a grand celestial clock ticking in place. Even Einstein had insisted that the universe must be balanced, neither collapsing nor expanding. To make his equations fit that belief, he invented something called the cosmological constant, a mathematical band-aid that kept the universe from flying apart. But when Hubble's data reached him, Einstein muttered that it had been his greatest blunder. The universe didn't need help staying still. It was born to move. That discovery turned astronomy into something poetic. Imagine standing on the deck of a ship and every other vessel in the ocean is sailing away from you, not because you're moving, but because the sea itself is stretching between hulls. That's how the universe behaves. You're on one of those ships watching the cosmic waves grow wider. The numbers Hubble found were tiny yet profound. For every megaparsec of distance, about 3.26 million light-years, galaxies moved away at roughly 500 kilometers per second. That's 1,000 times faster than the space shuttle ever traveled, but across such immense distances it still felt like a lullaby, a slow drift written in light. Here's where the fun contradiction lives. Galaxies aren't flying through space like bullets. They're mostly staying put in their little pockets of gravity, while the fabric between them stretches. It's a subtle but crucial difference motion without movement, travel without travelers. Even now when you look up at Orion or the Milky Way, you're gazing into that ongoing revelation. Each point of light is a messenger from a past, when the universe was slightly smaller, slightly younger, slightly denser. The redshift Hubble saw is still happening, encoded in every photon that touches your eyes. You're a witness to the aftermath of discovery, carried along by the same expansion that baffled him. Scientists still argue about how Hubble's constant has changed over time. In fact, they can't quite agree on its exact value today. Measurements from nearby stars and distant cosmic radiation disagree by just enough to cause restless nights in astronomy departments. Is the universe expanding faster now than our models predict, or are we missing a key piece of the puzzle? The debate is polite, but it hides a deep tension. Maybe our understanding of space-time or gravity itself isn't complete, and yet that uncertainty has its own comfort. The universe is large enough to keep secrets. There's another quirky twist. Hubble wasn't the first to imagine expansion. Years before his famous graph, a Belgian priest named Georges Lemaitre had derived the same conclusion from Einstein's equations. He even proposed what would later be called the Big Bang, that the universe began from a primeval atom. The idea was radical, almost impolite in its audacity. When he shared it, many scientists laughed it off. But time and a few billion data points proved him right. Lemaitre's cosmic atom had simply become cosmic truth. Picture that moment in history, two men, one armed with a telescope, the other with mathematics and faith, both peering into infinity and realizing it was stretching. Neither could have known that their quiet insights would one day help you fall asleep. Yet here you are, tracing their legacy through the faint hum of your fan. The discovery of expansion also changed how we see beginnings. Before Hubble, eternal felt safe, a universe without origin, no awkward questions about first causes. After Hubble, eternity became an unfolding story, not a fixed picture. Everything had once been closer, hotter, brighter. The galaxies, the stars, the atoms in your blood, they all share a single glowing childhood. The next time you watch dawn creep into the room, think of Hubble's telescope pointing at the dawn of everything. Each photon he captured had travelled millions of years to whisper the same message: we are still moving apart. It's the most patient sentence ever spoken. There's also something quietly humorous about the human part of it. Hubble, for all his fame, wasn't exactly thrilled by the philosophical weight of what he'd found. He treated expansion as data, not destiny. Meanwhile, philosophers and poets ran wild. They compared galaxies to balloons, symphonies even to loaves of raisin bread rising in an oven each, raisin drifting from its neighbours as the dough swells. You can almost smell the universe baking itself. So tonight as you lie here, you're wrapped in the aftertaste of that discovery. The air around you, the atoms inside you, the photons passing through your window, all are subject to the same slow stretch Hubble measured. You can't stop it, and you don't need to. If you close your eyes, you can picture him standing there in 1929, chalk in hand, drawing a line that tilted up with the first visual proof that creation wasn't finished. Every dot on that line, every distant galaxy was a note in an ever-rising song. You're still hearing it now, even if it's silent. Somewhere light that left its home before humans learned to walk is still on its way to us, redder, fainter and older with each passing moment. It's the universe's heartbeat, stretched thin but still beating. And maybe that's the most relaxing part of all, that you live in a world that's still unfolding. Nothing static, not even silence. The cosmos breathes and you, tiny and temporary, breathe with it. You can rest in that motion. It's the one thing that will never stop. You picture that faint static on an old TV screen, the speckled snow between channels that hums when no signal comes through. You might not realize it, but part of that snow is the oldest light in existence. It's called the cosmic microwave background, the afterglow of the Big Bang. Every time you saw that flicker as a kid, a few of those pixels were tiny messengers from the moment the universe was born. It's not poetic exaggeration. It's literal physics. About 13.8 billion years ago, the young universe was a glowing fog of plasma so dense and hot that light couldn't travel freely. Photons kept bouncing off electrons and protons trapped in a cosmic mosh pit. Then after roughly 380,000 years, it cooled just enough for atoms to form. The fog cleared and light finally escaped. That light has been travelling ever since, stretched by expansion, until it now glows faintly in microwaves. It fills every inch of space, including your living room right now, with a warmth of about 725 degrees above absolute zero. If you could see it, the entire sky would glow evenly in every direction, a soft baby blue haze. But you can't, because our eyes aren't tuned to microwaves. Scientists, however, can. In 1965, two radio engineers named Arno Penzias and Robert Wilson stumbled upon that signal by accident while working with a giant horn-shaped antenna in New Jersey. They thought they'd found pigeon droppings, literally. They scrubbed the dish, chased the birds, recalibrated the equipment, and the hum was still there. It turned out to be the echo of creation itself. That discovery won them the Nobel Prize and gave humanity its first direct glimpse of the universe's infancy. The light they caught had been travelling for nearly 14 billion years a record-breaking game of cosmic tag. And it's still playing now, wrapping around you as you drift towards sleep. Scientists still argue whether the tiny temperature variations in that glow are random or hold deeper meaning. When satellites like COBE-UMAP and Planck mapped the sky, they found minute differences, parts just slightly warmer or cooler by a few microkelvin. Those faint freckles are the seeds of everything. Over billions of years, gravity turned them into galaxies, clusters, and vast cosmic filaments. Imagine if every wrinkle in your bedsheet eventually became a city of stars. That's how those tiny ripples shaped the cosmos. There's something soothing about that inevitability. Out of chaotic brightness came gentle structure. Out of randomness, order slowly unfolded. If you ever doubt that peace can emerge from noise, remember the entire universe started as static, and it grew into you. The cosmic microwave background CMB, if you want to sound impressive at parties, is like a baby picture of everything. Astronomers study its patterns the way genealogists study family photos searching for resemblance symmetry or hidden lineage. The CMB tells us not just that the universe expanded, but how fast, how flat, and how balanced it is. It's the most accurate snapshot we've ever taken of cosmic childhood. One of the quirkiest facts. The temperature differences are so tiny that if you converted them into music, they'd sound like an ultra-low hum, something between a bass note and a slow heartbeat. Scientists have literally played the CMB by turning its data into sound. It's eerie and calming, like listening to a memory breathe. And yet even this perfection has a mystery. There's an odd asymmetry in the CMB, a cold spot that's too large to explain by random chance. Some researchers think it's the imprint of a supervoid, a region of space with fewer galaxies. Others wonder if it's evidence of something beyond our observable universe, perhaps even a collision with another cosmos. Scientists still argue, of course. That's what keeps telescopes pointed upward. As you lie here, the CMB hums invisibly through your body. Photons that began their journey when there were no stars, no planets, not even atoms are sliding through you, calmly ignored by your skin and bones. You are at this moment bathed in the light of creation, an ancient warmth too soft to feel, but too constant to escape. Sometimes cosmologists call this background radiation the surface of last scattering. It's the oldest horizon. We can see the limit of what light can tell us. Beyond it lies silence, or perhaps something stranger. You can imagine that boundary as a shimmering membrane surrounding the observable universe, expanding as we do. Every second new space comes into being, but that ancient light lags behind like the fading memory of a newborn's first cry. If you could float outside your galaxy and look back, you'd see that faint glow everywhere like the dim embers of a universal fireplace. It would be perfectly even except for those subtle ripples, tiny whispers of what would one day become everything you know. The CMB is proof that the universe not only expands but remembers. It's a cosmic diary written in microwaves instead of ink. When you think about it, that's what all of us are doing, trying to leave traces that say I was here. The universe did it first. You turn your head slightly and for a second the room feels enormous, as if your ceiling has fallen away and the night sky's pouring in. It's an illusion, but a comforting one. The space around you isn't empty, it's filled with light older than time as you know it. And it's still expanding quietly like a breath that never ends. You don't have to chase that light. It's already here. It's always been here. And maybe that's the strangest and most peaceful truth of all. Even in infinite expansion, the past is never really gone. It just grows softer, colder, and more beautiful. You might think the universe has a speed limit. After all, light itself obeys one. Nothing we're told can move faster than 299,792 kilometers per second. It's the cosmic do not exceed sign. And yet galaxies billions of light years away are slipping beyond that limit right now, receding from us faster than the light can travel. How? Because they aren't moving through space at all. Space itself is stretching between us, carrying them away on an invisible conveyor belt that needs no engine. This is one of those paradoxes that makes cosmology sound like a bedtime riddle. You can't outrun light in space, but space can outgrow light itself. It's as if the racetrack keeps lengthening while the runner sprints in place. The finish line recedes faster than any contestant can hope to reach it. Somewhere out there, the expansion is so rapid that light leaving a galaxy will never not in all eternity reach us. Those galaxies have slipped over the cosmic horizon, fading into a permanent dawn. It's tempting to imagine them as lost, but really they're just beyond communication, like friends on opposite shores of an ever-widening sea. Their light stretches endlessly wavelengths, pulled longer until they fade into nothingness. You could call that tragic, or you could call it serene. The universe doesn't mourn what it loses, it just keeps breathing out. Einstein saw the first hints of this before Hubble confirmed it. His general theory of relativity didn't just describe gravity, it described space-time as something that could bend, flex, and stretch. Gravity wasn't a force pulling things together, but the curvature of space caused by mass. You drop a marble on a trampoline, and smaller marbles roll toward it not because they want to, but because the surface itself dips. The same physics that lets planets orbit stars also allows space itself to swell. Scientists still argue whether expansion is infinite or merely very large, but they agree on one thing: it's not an explosion. It's not shrapnel flying through pre-existing nothingness. It's creation of space everywhere at once. When you look at distant galaxies moving away, you're not seeing them flee a central blast. You're seeing the distance between you and them grow, because new space keeps being woven between you. And here's where the imagination stretches even further. Because space is expanding, the light travelling through it also stretches. Its colour shifts toward red, its energy thins out, and its pace slows from our perspective. A blue star born billions of years ago may now reach us as a ghostly crimson whisper. Scientists call this the cosmological redshift, but you can think of it as cosmic fatigue. Even photons get tired. In that way, expansion isn't just physical, it's emotional. Every bit of light is a letter from the past, arriving a little paler, a little quieter. The farther away it came from, the sleepier its message becomes. Somewhere beyond our reach, entire galaxies exist as pure silence, now their light too stretched to see their stories still unfolding unseen. One of the most beautiful consequences of this rule is that the night sky you see tonight isn't the present at all, it's a mosaic of ancient moments. The Andromeda galaxy shines as it looked 2.5 million years ago. The light of the farthest quasars began its journey when Earth was still a cooling ball of rock. You live surrounded by the past, wrapped in echoes that took billions of years to reach you. If you listen closely, even darkness is speaking. You might wonder if galaxies can disappear beyond the horizon. Does that mean our universe is becoming lonelier? The answer depends on your patience. On cosmic timescales, yes. Each galaxy outside our local group will one day fade away, redshifted into invisibility. Billions of years from now, distant observers in the Milky Way might look up and see only a dark sky with a few nearby stars, unaware that a grand cosmic sea ever existed beyond their shores. The future of the universe is a slow, graceful retreat into solitude. But for now, the light is still arriving. The cosmic horizon sits about 46 billion light-years away in every direction. Beyond that space is expanding faster than light can keep up. The idea itself is strangely comforting. You don't need to chase infinity because it's already busy making more of itself. There's a quirky footnote here: although expansion carries galaxies apart, gravity can locally reverse it. Inside clusters, galaxies are bound tightly enough that they orbit one another like dancers locked in embrace, ignoring the cosmic wind. The Milky Way and Andromeda are doing just that. In about 4 billion years, they'll collide not as explosions, but as a slow interweaving of stars' gas and silence. So even as space stretches, gravity writes love letters in spirals. Sometimes physicists compare the whole thing to a rising loaf of raisin bread. The dough is space, the raisins are galaxies. As the loaf bakes, the dough swells, and the raisins move apart not because they're crawling away, but because the space between them increases. Some raisins trapped close together might clump into a chewy cluster, while others drift far off into the crust of eternity. If that image makes you hungry, congratulations, you've just connected cosmic dynamics to breakfast. And yet it's humbling to remember that the universe's speed limit wasn't broken. After all, it was reinterpreted. Einstein's law still stands. Nothing travels faster than light through space, but space itself is free to stretch however it pleases. The cosmos plays by its own rules, and they are oddly fair. So tonight, as you lie in bed, consider that somewhere billions of light years away, galaxies are already gone, not destroyed, just unreachable. Their light is on the road, elongating, cooling, fading. It will never reach us, but its absence doesn't feel like loss. It feels like permission to rest, to expand in our own quiet way, to understand that everything, even separation, can be peaceful. You are inside the slowest, largest miracle imaginable. The race between light and expansion has no finish line, and no losers, only distance, only time, only the soft rhythm of an ever-growing space where everything belongs. You lie there in the dark, and it's strange to realize that gravity, The same invisible pull that keeps your body snug against the mattress is quietly competing with the expansion of the universe. Two great forces opposite in temperament: gravity pulling inward with patient persistence, expansion pushing outward with infinite gentleness. Neither one makes a sound, yet together they compose the rhythm of everything that has ever existed. If expansion is the universe's exhale, then gravity is its inhale. From the beginning, these two have been locked in a cosmic conversation. When the universe was young, gravity had the louder voice. Matter was dense, hot, and eager to clump together. Galaxies formed, stars lit up, and planets coalesced. But as time passed and the cosmos thinned out, expansion began to win its soft, steady push, overcoming the pull of everything that tried to hold on. Scientists still argue about the fine details of this balance. Some call it the cosmic tug-of-war, a slow contest measured not in minutes or years, but in billions of years. For the first 9 billion years, gravity seemed to have the upper hand, sculpting galaxies and stars. Then something changed. Expansion began to accelerate. The unknown force we now call dark energy took the lead, as if the universe decided it had clung to itself long enough and finally let go. That letting go wasn't violent, it was tranquil. Think of a balloon slipping from your hand and drifting upward into a pale morning sky. You don't hear a sound. You just watch as it rises smaller and smaller until it becomes a dot against the clouds. That's how galaxies drift apart, carried by the invisible breath of dark energy. The scene feels calm, almost inevitable. Gravity, for all its strength, is patient too. It's what builds everything that expansion spreads out. Every planet, every heartbeat, every orbit is an act of resistance against dispersion. When you drop an apple, gravity is reminding you that not all parts of the universe are content to drift apart. It's the ultimate homemaker, keeping stars cozy in their spirals, while the cosmos continues to stretch beyond them. Without gravity's quiet persistence, you wouldn't exist to notice expansion at all. Stars would never have fused hydrogen into heavier elements, never released carbon or oxygen into the interstellar medium. No atoms would have clumped into water, no planets into havens for life. Expansion alone gives us room to exist. Gravity gives us the structure to stay. There's something deeply human about that partnership. We spend our lives balancing expansion and gravity. 2, reaching outward for new things, holding inward to what matters. The universe mirrors the same rhythm that plays inside you: breath in, breath out connection, and release. Astrophysicists often describe this dynamic, using what's called the critical density, the precise amount of matter and energy needed to balance expansion and collapse. If the universe contained just a little more mass, gravity would eventually pull everything back together into a big crunch. A little less and galaxies would tear apart faster than they could form. Somehow impossibly, the universe hit the sweet spot, an almost perfect equilibrium. Scientists still debate why. Some think it's luck. Others suspect an underlying principle we haven't discovered yet. But to you lying here listening to the quiet, it feels like grace. The cosmos, against all odds, got it just right for life to unfold. The equations balance so precisely that if the density had been off by 1 part in 100,000, there would be no galaxies, no stars, no you reading this now. It's easy to imagine gravity as cold mathematics, but it's also warmth. Every time you feel your weight pressed gently against the sheets, that's gravity's tender insistence that you belong here on this small planet, orbiting a modest star. It's the oldest embrace in the universe, reaching back to the first particles that ever fell toward one another. Even the grandest collisions, black holes merging galaxies entwining, follow this same rule of balance. What looks violent from afar is at its heart the cosmos' way of keeping the dance going. Expansion opens the floor, gravity choreographs the steps. One gives freedom, the other gives form. Neither wins because each defines the other. If you could somehow zoom out far beyond the Milky Way, beyond the filaments of superclusters, you'd see that gravity and expansion coexist in serene harmony. Galaxies cling together in clusters, but the clusters drift apart, separated by growing gulfs of nothingness. It's like watching the tide pull sand into small piles, while the shoreline itself recedes, stillness and motion together. There's even a gentle humour in how nature hides this drama from us. Every atom in your body is bound so tightly that you can't feel the universe is stretching at all. You could lie there for 1,000,000 years, and your coffee cup would stay the same size. Gravity and electromagnetic forces simply ignore expansion within their domains. On the human scale, the cosmic tug-of-war ends in a draw, And that's the beauty of it. The universe's greatest struggle produces perfect calm right where you are. While galaxies drift apart at unimaginable speeds, your heartbeat sinks with gravity's pull steady and small and sure. So as you breathe, you can think of it this way. Every inhale echoes the force that builds worlds, and every exhale mirrors the expansion that carries them apart. The two forces never stop arguing, but neither ever raises its voice. If the universe were a song, gravity would be the bass note holding everything together, while expansion would be the slow fade that lets the melody drift into silence. And tonight you get to lie right in the middle of that harmony, listening to it without ears, feeling it without effort. The war between gravity and expansion isn't meant to be won. It's meant to be lived in peacefully, one breath at a time. You picture the night sky, a spray of light pinned to black velvet, and realize something subtle. Even though the universe is stretching, the stars in your sky aren't drifting away from one another. The Big Dipper still looks like a ladle. Orion's belt is still in line. Centuries pass and the constellations barely change. If everything's expanding, why doesn't the sky fall apart? The answer is almost domestic. Galaxies, like neighborhoods, resist the pull of expansion within their own property lines. Gravity and dark matter hold them together so tightly that space's gentle stretch barely stirs them. It's as if the cosmic fabric has tiny pockets of stitching places where matter has gathered enough to anchor itself against the flow. These are the galaxy clusters, the gravitational safe houses scattered across the universe. Your own Milky Way is one such island. It spins serenely, billions of stars bound by their mutual pull, ignoring the universe's invitation to drift apart. If expansion could whisper, it might murmur, "Come on, it's time to go," and gravity would smile and say, "We're fine right here." Scientists still argue how strong those bonds really are. Dark matter, that invisible scaffolding of the cosmos, is the main suspect holding everything together. We can't see it, but we feel its presence in the way galaxies rotate. The outer stars move faster than they should, as if pulled by something unseen. Without dark matter, galaxies would fly apart like glitter tossed into the wind. Whatever it is, this mysterious substance keeps local regions immune to expansion. It's the universe's way of making sure that even in eternal motion, there are places that stay home. Imagine space as an ocean. Most of it is a calm rising tide, but scattered across its surface are whirlpools, galaxies and clusters, where gravity circles the water into beautiful patterns. Inside those eddies, expansion loses its voice. You, the Earth, the Sun, and the stars of the Milky Way are all swimming inside one of those cosmic whirlpools, perfectly sheltered from the larger current. Every time you look up, you're seeing light caught in that swirl. Our Sun orbits the galactic center every 230 million years along with the rest of the spiral arms. Thick ribbons of starlight gas and dark matter twine together. The galaxy is a glowing city floating in a universe of ever-widening dark. Expansion happens all around it, but not within it. And here's the tranquil paradox: the faster the universe expands, the quieter your little pocket becomes. Distant galaxies drift away so quickly that their light stretches beyond visibility. The farther they go, the less their gravity can touch us. Eventually, only our local group of galaxies, the Milky Way, Andromeda, and a handful of small companions will remain in mutual company. Everything else will recede beyond the cosmic horizon, leaving our sky simpler, emptier, calmer. It sounds lonely, but it's also elegant. A universe so vast that it gives every cluster its own privacy. Each galactic island will keep its stars and histories, its nebulae and remnants, bound together in a kind of eternal dusk. Imagine living on a beach where the tide keeps going out, but your small tide pool stays intact, filled with little lights that never fade. That's what our galaxy is, a cosmic tide pool under an infinite moon. Scientists still debate what dark matter actually is. Some say it could be made of unseen particles that barely interact with normal matter. Others suspect it's a property of gravity itself, something our equations haven't yet learned to describe correctly. Whatever the truth, dark matter is a kind of cosmic compassion. It holds things close when the rest of the universe is letting go. There's another unseen ally too, dark energy working on the opposite scale. Together they form a perfect duet. Dark matter binds, dark energy unbinds. The balance between them defines everything you see in the sky. Without dark matter, galaxies wouldn't have formed. Without dark energy, the universe might have collapsed back on itself. Between the two lies just enough tension to keep creation in motion without tearing it apart. Think of your own life, the balance between what holds you and what lets you drift. family memory, gravity, they keep you grounded. Curiosity, time, expansion, they pull you outward. The same story plays out on a galactic scale, and it's oddly comforting. You don't need to fight the drift, you just need to hold what matters. Some nights astronomers use powerful telescopes to peer at distant clusters, smudges of faint light billions of light years away. Those clusters are like postcards from the early universe still holding together across unimaginable distance. Their glow is proof that gravity's patience is stronger than expansion's whisper. If you could zoom out far enough, you'd see the universe as a web of these islands, vast filaments of galaxies connected by dark matter with immense voids between them. The cosmic web stretches, but the threads themselves are tough. Each filament resists for a while like a silk strand trembling in a slow breeze. That's what you live inside, a resilient pattern of light, bound yet expanding, delicate yet enduring. Even your body reflects this duality. Atoms within you resist expansion, yet the space between galaxies in your chest between electrons and nuclei is mostly empty, stretching gently with the rest of the cosmos. You're a walking contradiction, both static and expanding, gravity-bound and space-blown. So when you look up and wonder why the constellations haven't scattered, remember gravity and dark matter are tucking you in. The stars hold their shape so you can navigate by them, dream under them, and feel at home beneath an ever-growing sky. You don't have to chase the galaxies that are leaving. The ones that stay are enough. The universe is vast, but it's also local, and that local patch, the quiet spiral arm, the familiar night, is your refuge from infinite expansion. The stars above you tonight are proof that even in a universe built on motion, there are places that choose stillness. You've been floating in this thought for a while that space itself is growing quietly everywhere at once. But the question that always sneaks in, the one that hums just beneath the surface of every astronomy documentary, is why? Why is the expansion not slowing down, not coasting to rest, but speeding up? What is pushing the galaxies apart faster and faster, as if the universe has decided to stretch for good? The answer, or rather the placeholder for one, is what scientists call dark energy, a name that tells you almost nothing and hides a great deal. It's not dark like shadow, and it's not energy like the electricity humming in your lamp. It's simply the label for whatever it is that's making the cosmos accelerate. Roughly 70% of everything around you, everything that exists, is made of this invisible pressure. It fills the vacuum of space and behaves as if emptiness itself had a personality it wants to expand. You might imagine dark energy as a kind of cosmic sigh, an outward exhalation that never stops. It doesn't push things apart like wind. It makes more of the in-between. Space grows because there's something built into its fabric that insists on stretching. And yet no one knows what it truly is. Scientists still argue whether dark energy is constant everywhere or if it changes over time. Some think it's the cosmological constant Einstein once added to his equations, his so-called biggest blunder that turned out to be prophetic. Others think it might be a new field altogether, something dynamic that waxes and wanes like the weather of the vacuum. A few even whisper that maybe our understanding of gravity itself is incomplete, that what we call dark energy is simply nature using a different rulebook. Whatever the truth, the evidence is overwhelming. In the late 1990s, two teams of astronomers studying distant supernovae noticed something odd. These ancient explosions were dimmer than expected, too far away for the simple deceleration model of the universe. That meant the expansion had sped up. The cosmos wasn't just coasting on leftover momentum from the Big Bang. It was being pushed by something new. When the news broke, even seasoned physicists blinked. The universe, it seemed, had changed its mind. And all around you tonight, that invisible influence is still at work, lengthening the distances between galaxy clusters while you breathe without noticing. There's a gentle irony to it. The more space expands, the more dark energy there is, because dark energy is space. Each new cubic meter of nothingness carries its own faint push. It's a runaway process, but so slow that it feels eternal. You could live 1,000,000 lifetimes and the stars in your sky would barely move. The acceleration is vast in scope, but whisper-light in speed, a background rhythm measured not in seconds, but in billions of years. If you want to feel how subtle that is, stretch your hand in front of you. In the time it takes for your pulse to beat, once the space between your fingers has grown by less than 1,000,000,000th of a centimeter, you're technically expanding. Congratulations. The effect is so small that your atoms laugh at it. But scale it up across galaxies and you have a force powerful enough to decide the universe's fate. The strangest thing, dark energy doesn't clump. It doesn't gather into stars or planets or even clouds. It's perfectly uniform, like a calm fog that fills all of space equally. Because of that, it doesn't pull it, only pushes. It's the ultimate minimalist, structureless, odorless, invisible, and yet ruling the cosmos by quiet suggestion. Sometimes physicists nickname it the vacuum energy, the latent hum of quantum fields that never fully rest. Even the emptiest point in space vibrates with virtual particles blinking in and out of existence. If you could zoom in close enough, you'd see a sea of microscopic fireworks, constant and random. Each flash carries a tiny push outward, the collective result, the accelerating universe you live in, and yet the math doesn't quite fit. The quantum prediction for vacuum energy is 120 orders of magnitude stronger than what we observe, meaning if the theory were literally true, the universe would have blown itself apart before it even began. So somewhere, something cancels most of that energy out. Why, nobody knows. It's called the cosmological constant problem, and it keeps brilliant people awake at night. Well, not tonight, you're allowed to fall asleep to it. The comforting thought is this: whatever dark energy is, it's gentle. It doesn't rip atoms apart or crush galaxies. It works on the grandest scales, only shaping the long story of time. In the here and now, it's a lullaby, steady, predictable, strangely kind. Imagine lying in a field beneath a cloudless sky, feeling the Earth's faint spin beneath you. Everything feels still, but you know the planet moves. The same illusion holds for expansion, stillness and motion simultaneously true. You can live your whole life inside it and never once notice the fabric stretching. Yet it defines every future horizon. Some cosmologists like to call dark energy the breathing space of the universe. Without it, gravity would pull everything back into a dense, fiery knot. With it, the universe relaxes, unfolding into open calm. There's beauty in that balance. The cosmos found a way to keep itself alive, not through violence, but through expansion. You might not have asked for physics tonight, but physics has given you peace. The room around you is part of the same quiet process that carries galaxies apart. Even your breath adds a small echo to that cosmic rhythm. Inhale gravity, exhale dark energy. The two have never stopped talking. So as you close your eyes, picture that trillions of galaxies suspended in the black, drifting outward on an invisible tide powered by something softer than air. You can't see it, you can't touch it, but it holds everything together by pushing it apart. And somewhere in the middle of that paradox, you fall asleep. You drift deeper, and in that half-dream space, you start to imagine the beginning. Not the Big Bang itself, but the breath before it, if such a thing existed. For the universe to be expanding now, something had to set it expanding then, and not slowly, but explosively fast. Astronomers call that brief, impossible instant inflation, though the name makes it sound like a balloon instead of a miracle. It happened in less than a trillionth of a second. One moment the cosmos was smaller than an atom, the next it had ballooned to cosmic size. That flash of expansion was faster than light, not because anything broke the rules, but because space itself was allowed to stretch as quickly as it pleased. Every region of the newborn universe grew apart from every other, smoothing out irregularities and setting the stage for galaxies yet unborn. If that sounds abstract, picture a sheet of fabric being yanked in every direction at once. The wrinkles disappear, the threads straighten, and the weave becomes nearly uniform. Inflation was that cosmic ironing. Without it, the universe today would be lumpy and uneven, maybe even collapsing back on itself. Instead, it came out remarkably flat-balanced and calm, like a bed freshly made by the laws of physics. Scientists still argue about what triggered this inflation. Some think it was a peculiar field of energy, imaginatively called the inflaton, that briefly dominated everything, then decayed into matter radiation and the seeds of galaxies. Others propose that inflation never truly stopped, that it continues in distant regions, endlessly spawning new universes like bubbles in a boundless foam. Each bubble would have its own physics, its own stars, maybe even its own curious creatures wondering about expansion. That idea, eternal inflation, means that what you call the universe might just be one room in an infinite mansion. You live in a bubble that cooled and slowed, while beyond its unseen walls new bubbles are still being blown. The night sky above you could be just a fraction of an endless unseen sea. If that makes your brain ache, good. The universe is supposed to be too large to fit in one head. Even physicists who devote lifetimes to the subject admit that inflation's cause and duration are still a mystery. We don't really know why the universe inflated, they confess, with a shrug that is half humility, half awe. But it seems grateful that it did. And you can be grateful too, because inflation solved several cosmic riddles in one elegant sweep. It explains why the cosmos looks the same in every direction, why it's so perfectly flat, and why the tiny ripples in the cosmic microwave background were just right to form galaxies. It's like discovering the secret recipe that made existence come out just so. There's even something endearingly human in the way scientists try to model it. They picture quantum fields, swelling and decaying equations spinning across chalkboards, simulations blooming on computer screens. Yet underneath all that math lies a simple picture. The universe took a deep breath, and in that breath everything began. You can almost feel it if you slow your own breathing to match the imagined rhythm. Inhale, the fabric of space tightens. Exhale, it expands beyond comprehension. Inflation wasn't loud. It didn't roar like an explosion. It was smooth, silent, unstoppable, like the first ripple on a perfectly still pond. If you could have stood there, not that there was any there to stand on, you wouldn't have seen a flash of light or heard a sound. You would have felt only expansion, the stretching of all possible directions at once faster than time could count. And within that instant, quantum fluctuations, tiny jitters of energy, were frozen into the structure of the universe destined to become galaxy stars, and eventually the ground beneath your bed. The strangest part is how inflation connects the microscopic and the cosmic. It took the random tremors of quantum particles, magnified them, and turned them into the architecture of everything. The wrinkles on space-time became constellations. A quantum sneeze became the Milky Way. If that doesn't make you smile, nothing will. Scientists sometimes call inflation the most successful theory we don't understand. It fits the data, it explains the sky, but no one can yet tell you exactly what drove it or why it stopped. It's a puzzle box that hums contentedly even when unopened. Maybe that's the charm of it. Some mysteries are meant to cradle you, not to be solved before bed. So as you settle deeper into the pillow, imagine that first breath of everything continuing inside you. The atoms in your body were once quantum ripples stretched by that same inflationary surge. You're in a very literal sense built from the vibration of the universe learning to expand. Outside your window, galaxies still drift apart on the momentum of that ancient impulse. Inside your chest, air moves in and out, mimicking the same rhythm. It's the oldest echo there is, the breath of the cosmos still exhaling after 14 billion years. You're still floating in that first light, that moment when everything was new. And it's time to look closer at what empty really means. Because as it turns out, there's no such thing. Even the emptiest space, the dark gap between galaxies, boils with activity. Physicists call it vacuum energy, though vacuum is a misleading word. It makes you think of absence of silence. But at the quantum level, emptiness hums. Everywhere in the cosmos, even in regions stripped of matter and radiation, the vacuum seethes with virtual particles, tiny flickers of existence that pop in and out faster than any camera could catch. One moment there's nothing. The next, a pair of particles bursts into being, touches, and disappears again. This happens constantly, like a quiet rain of creation and uncreation. It's this restless energy that scientists think might fuel the universe's expansion. You might imagine space as a still pond, but under the surface invisible fish leap in and out, creating tiny ripples you can't see. Those ripples accumulate. Over billions of years they may nudge galaxies apart, contributing to the soft acceleration we call dark energy. The vacuum, it seems, is not a void, but an orchestra, playing at frequencies too high for ears to hear. Here's a mind twister. If you remove every atom from a cubic meter of space, you don't get nothing. You get about 1096 joules of potential quantum energy, according to certain calculations. That's more than the energy of all the matter in the observable universe. Yet somehow almost all of it cancels out, leaving behind just the faintest residue. That tiny leftover, too small to measure directly, might be what's driving cosmic expansion. It's as if the universe can't help but fidget. Scientists still argue about how to reconcile that absurd difference. Some say our equations overcount. Others propose that positive and negative energies nearly balance but not perfectly. The mismatch, sometimes called the worst theoretical prediction in the history of physics, might also be the most profound clue we have that something about reality is deeper than we know. There's a quirk here that makes philosophers grin. The vacuum isn't just filled with energy, it also defines the rules of existence. The particles that flicker in and out give rise to the constants of nature, the charge of the electron, the speed of light, even the strength of gravity. change the vacuum and everything else changes too. You could say that the void sets the tone for reality, the way the hum of an engine sets the rhythm for a whole car ride. The thought that nothing can shape everything feels oddly poetic. You live inside a universe that expands not because it's full, but because it's never truly empty. The spaces between atoms, the gaps between stars, they all contribute to a grand invisible pressure that keeps creation unfolding. It's the softest push imaginable, but on the scale of the cosmos, it wins every time. There's even experimental evidence for this restless vacuum. In laboratories, physicists have detected what's called the Casimir effect, a tiny force that arises when two metal plates are placed extremely close together in a vacuum. The quantum fluctuations between them are limited by their proximity, creating a pressure that nudges the plates toward each other. You can measure it. It's proof that emptiness pushes back. The same principle scaled up unimaginably could be what's nudging entire galaxies apart. If that doesn't lull you, consider this: every cubic centimeter of your room right now is alive with those invisible flickers. They pass through your pillow, your skin, your breath, exchanging energy with the atoms of your body in constant quiet rhythm. The boundary between you and the universe isn't solid, it's a conversation. Matter, energy, emptiness. They're all phases of the same endless dialogue. Physicists sometimes describe the vacuum as a quantum foam. At the smallest scale, smaller than atoms, smaller even than quarks, space and time themselves may tremble like the surface of boiling water. Tiny wormholes form and collapse, minute curves of space-time flash in and out of the being. You're lying here on a bed that's floating atop that bubbling foundation, though you never feel it. The solid world is resting on the most restless sea imaginable. It's humbling to realize that this flickering vacuum has been humming since the beginning. The same energy that drove inflation, the same pressure that propels galaxies apart is still here under everything. It connects the cosmic and the personal, the vast and the microscopic. You are built from the residue of quantum fields, yet you sleep soundly in their embrace. Scientists still debate what will become of this restless background. Will it remain constant, forever stretching the universe into perfect coldness, or will it change, fade, or reverse? No one knows. But there's comfort in that uncertainty. The vacuum's restlessness is also the reason we exist at all. Without its quantum jitters, stars would never ignite, chemistry would never begin, and life would never emerge to ask questions about bedtime cosmology. So when you close your eyes and the darkness feels infinite, remember it isn't empty. It's alive with creation at the smallest imaginable scales. Every point in space holds a storm of potential, every silence a hum. The universe doesn't sleep. It gently vibrates even when you do. In the end, expansion isn't powered by noise or fire, but by quiet persistence, the endless background murmur of nothing that turns out to be everything. The cosmos keeps growing because its own emptiness refuses to sit still, and tonight as you rest, you join that rhythm. You're made of the same quantum fluctuations that still dance in the vacuum. You don't need to move. The universe moves for you. You can feel small without being separate still, without being stagnant. Even the calmest night carries the hum of becoming. You've been floating for a while through this vast and invisible tide, and it's time to look at what shape all this expansion actually takes. Because if the universe is stretching, the next natural question is into what is it curving, is it flat, is it looping back around like the surface of a balloon, or is it something so strange that words can only gesture toward it? Scientists call this the geometry of the universe, and it's one of the calmest yet most profound questions we can ask. The answer, as far as we can tell, is almost heartbreakingly simple. It's flat. Not flat like a table or a pancake, but in the sense that parallel lines will stay parallel forever. Shoot two laser beams side by side into deep space, and if you could somehow follow them for billions of light years, they would never meet. That doesn't mean space is two-dimensional. It just means that on the grandest scale, the fabric of space-time isn't curled inward or outward, it's balanced, like a perfectly stretched sheet. The discovery came from those tiny temperature ripples in the cosmic microwave background. When scientists mapped them with satellites like WMAP and Planck, the patterns revealed that the universe's geometry fits Euclid's old rules almost exactly. Within a margin of error of less than 1%, space is flat, and yet that perfect flatness is itself a mystery. Out of all the ways a universe could have been open like a saddle, closed like a sphere, it chose the narrow ridge of balance. Scientists still argue whether inflation is responsible for that precision. During those first fractions of a second, inflation would have stretched any initial curve until it smoothed out, just as the horizon on Earth looks flat when you're standing in a vast plain. The universe may be curved overall, but on scales we can see the curvature is too gentle to notice. It's like standing on a giant balloon so large you can't tell it's round. From your perspective, the ground beneath you feels endless and level, though you're walking across a curve. The cosmos works the same way. You're living on a patch of a surface so immense that even light, after travelling 46 billion years, hasn't found an edge to trace. But not everyone is satisfied with flat. Some cosmologists suspect there's a subtle curvature hiding just beyond our observational reach, a slight bend that could reveal itself if we could see far enough. Others entertain the idea that space might be finite, but unbounded, like the skin of a sphere. You could travel in a straight line forever and eventually end up where you started. Imagine that if you pointed a powerful enough telescope in the right direction, you might one day see the back of your own head billions of years younger. It's an absurd thought. The cosmology thrives on such absurdities. The geometry of the universe doesn't just describe its shape, it dictates its destiny. A positively curved closed universe would eventually collapse in a big crunch. A negatively curved open one would expand forever, thinning into nothingness. A perfectly flat one hovers in between, expanding eternally but ever more slowly. And ours, according to current measurements, seems just a hair toward eternal expansion, a quiet glide into infinity. That balance is eerie in its precision. If the density of matter and energy had been just slightly higher in the early universe by 1 part in 100,000, gravity would have won, pulling everything back. Slightly lower and galaxies would never have formed. Somehow the cosmos tuned itself to the knife edge between too much and too little. You can almost imagine a cosmic tightrope walker, arms outstretched, balancing effortlessly as she steps across eternity. Every star, every atom, every breath you take exists because the universe never lost its footing. There's an oddly personal comfort in that geometry. Flatness means predictability. It means no cosmic trick corners where light folds back on itself, or loops of time where effects precede causes. It means that the equations describing the fall of an apple also describe the motion of galaxies scaled up into grandeur. And yet the simplicity doesn't feel empty. It feels peaceful. A universe that expands evenly without abrupt warps or dead ends is a universe where everything has room. You live in a geometry designed for calm. If you could visualize this flatness, it would look like an infinite quilt stitched together from filaments of galaxies draped across the darkness. Each square of that quilt expands uniformly, but the pattern itself remains balanced. No corner frays faster than another. The result is a cosmos both dynamic and stable, restless yet harmonious. Scientists still debate the metaphysics of this equilibrium. Is it coincidence or a sign of something deeper, perhaps, that universes with such fine tuning are the only ones where consciousness can arise to ask questions? It's called the anthropic principle, and while some physicists roll their eyes at it, others find comfort in its poetry. The universe must be precisely this way, because otherwise there would be no one here to wonder about it. As you lie here, your body tracing the gentle curve of the mattress, you're in perfect agreement with that geometry. The sheets stretch evenly beneath you, no edges, no corners, just continuity. The shape of space mirrors the shape of rest. So if you ever worry about falling off the edge of the universe, don't. There isn't one. The cosmos doesn't end. It just keeps going smooth and unhurried. You can travel forever and never reach a wall, only more of the same gentle fabric, more stars fading quietly into distance. In that endlessness, flatness becomes a kind of comfort. The universe isn't a maze or a trap, it's an open field, and tonight that field is all yours. You're floating again, only now the silence feels alive with faint ripples, tiny tremors rolling through space itself. These are gravitational waves, the most delicate vibrations imaginable, traveling at the speed of light and stretching reality as they pass. They don't move through space like sound through air, they are space-moving. If the cosmos were a vast pond, gravitational waves would be its surface, trembling after a distant stone drop. When Einstein first predicted them in 1916, he wasn't sure they were real. His math said that massive bodies like orbiting stars should create ripples in space-time, sending energy outward in waves. But he doubted they could ever be detected. They were too faint, stretching and squeezing distances by less than the width of a proton. For a century, they remained a beautiful theory, a whisper of music no one could hear. Then in 2015, that whisper became a sound. two black holes, each about 30 times the mass of the Sun, spiraled into each other a billion light-years away. Their collision sent a shockwave through space-time that finally reached Earth, and humanity had built the perfect instrument to listen: LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO is an almost poetic piece of engineering: 2 long tunnels of vacuum, 4 kilometers each, laid out in an L shape. Lasers bounce between mirrors at the ends, measuring distances with impossible precision. When a gravitational wave passes the arms of the L stretch and shrink by a fraction of a proton's width, and the interference pattern of the laser light shifts. The signal is tiny but unmistakable. The day it was first detected, scientists cried. They'd heard the universe ring like a bell. The sound converted into audio frequencies was a brief chirp rising in pitch as the black holes spiraled closer, then cutting off as they merged. It lasted just 2 seconds, but that half note carried the story of a billion-year journey. You could say it was the universe clearing its throat after 13.8 billion years of silence. Since then, LIGO and its twin observatories, Virgo in Italy and Kagra in Japan, have recorded dozens more events: neutron stars colliding black holes, merging, even cosmic tremors that might hint at stranger things. Each one confirms the same idea: space-time is not rigid, but elastic, capable of vibrating like a drum. The universe, it turns out, is musical. Scientists still argue what other symphonies might be out there. Some hope to detect primordial gravitational waves, ripples left over from the universe's first fraction of a second, created during inflation. These waves would carry direct proof of that early cosmic growth spurt frozen into the microwave background as faint spirals in its polarization. If detected, they'd be like hearing the echo of creation itself, a sound older than light. But for now, we live in a lull between those grand notes. The waves that reach us today are gentle, subtle, perfectly harmless. As they pass through you, your body literally stretches and compresses ever so slightly, too small to notice, but measurable by machines. You're being serenaded by colliding stars without even feeling it. It's funny to think about right now. Somewhere across the universe, 2 black holes are dancing. They whirl around each other faster and faster, twisting space-time into ripples that travel billions of years to find you. And when they finally arrive, those ripples don't knock, don't roar, they simply pass through, whispering a faint, perfect vibration before fading back into silence. The thought is both humbling and soothing. You don't need to see everything to be part of it. The universe is constantly in motion, yet it treats you gently. Gravitational waves pass through walls, planets, people, even atoms, as easily as light through a window pane. They prove that you live in a universe that can move without breaking, flex without snapping. In that way, they are the physical counterpart to calm. When you stretch, when you sigh, when you adjust the blanket over your shoulder, you're participating in a smaller version of the same phenomenon: gentle waves moving through a stable structure. Space does this all the time, you just don't feel it. Some physicists like to say that gravitational waves are the universe's way of gossiping. Every massive event sends out news of itself at light speed. If we had the ears for it, the cosmos would never stop murmuring the fall of stars, the births of black holes, the quiet hum of galaxies orbiting. All of it rippling outward, blending into a background hum that never truly ends. And that brings a strange peace. Because if the universe is full of waves, then stillness doesn't mean nothingness, it means perfect harmony. Everything vibrates together, from the atoms in your chest to the fabric of space between galaxies. There's no conflict in that motion, only continuity. You can almost imagine it, the Milky Way gently bobbing on unseen swells, every star rocking, in time to a beat you'll never hear. The expansion of the universe doesn't erase these ripples. It carries them, stretches them, preserves them as part of the great flow outward. So the next time you feel small, remember the same gravitational waves that move mountains also move through you. You're not separate from the cosmos, you're made of it, moving with it, humming at its frequency. If you listen closely, not with your ears, but with that quiet awareness that comes just before sleep, you might almost sense it, a steady vibration, ancient and patient, gently passing through your pillow and your pulse. That's the sound of space itself saying goodnight. Somewhere in that slow hum of space-time light itself begins to stretch. You can picture it: waves of brightness pulled longer and longer until their color changes. The redshift scientists call it. It's the universe's way of aging light, a cosmic yawn that lengthens every photon's stride. You might think of it as the Doppler effect for existence, just as a siren drops in pitch as it moves away. The the glow of distant galaxies fades to red as expansion carries them farther into the dark. When astronomers peer deep into the cosmos, they're not seeing speed, they're seeing time itself. A galaxy whose light is shifted twice as red as normal isn't just distant, it's ancient. That light left before the sun existed, maybe before our galaxy's spiral arms fully formed. Expansion doesn't just stretch space, it stretches the meaning of now. Imagine for a moment shining a flashlight into the sky. Every particle of light each photon leaves at the same speed, but as it travels space itself expands, pulling the wave apart. By the time it crosses billions of light years, it's so elongated that it drifts out of the visible spectrum, entirely fading into infrared, then microwave, then radio. Some photons have been stretched so long they hum at frequencies lower than your heartbeat. That's what makes the night sky so tranquil. It's not static. It's tired light reaching us across an ever-widening gulf. Even the Milky Way's glow has been gently reddened by time, its wavelength softened like the aging of a favourite photograph. The expansion of the universe is in a way a cosmic sepia filter, turning youthful blues into mature golds, energetic bursts into calm whispers. Scientists still argue over how exactly time behaves across this stretching fabric. In the expanding universe, clocks don't tick uniformly. To observers billions of light years apart, the same event can seem to unfold at different speeds. Distant galaxies appear to move and evolve in slow motion, their flickering supernovae unfolding more leisurely than ours. You could watch a star explode out there and see it burn not for seconds but for hours. Expansion slows their drama into dreamlike tempo. It's not just light that stretches, time itself stretches. When you gaze at a faraway galaxy, you're looking at its past, but you're also glimpsing time moving differently there. Every photon that enters your eye carries not just colour, but a timestamp altered by the swelling universe. The farther you look, the slower everything seems. Somewhere 10 billion light years away, a star is flickering right now, and to you its heartbeat is frozen in amber. Physicists call this cosmic time dilation, and it's one of the most poetic consequences of expansion. The deeper you gaze, the more the universe slows down like a film reel unspooling into infinite frames. It's why the cosmos always looks calm, because the farther we look, the more expansion stretches motion into stillness. The entire universe is, in that sense, perpetually in slow motion. You, on the other hand, exist in the fast lane. Your seconds zip by at local speed. The atoms in your skin buzz and hum, clocks tick, hearts beat. But all around you, light from distant galaxies is crawling, dragging its colour like a painter pulling a brush through molasses. You live in a sea of slow light. Scientists love this redshift because it's the ruler of the universe. Measure it carefully, and you can tell how far away something is, how fast it's receding, even how old the cosmos was when the light began its journey. It's the cosmic equivalent of tree rings, each redshift marking a deeper layer of time. Astronomers catalogue these shifts like historians catalogue years. The light from galaxies at redshift 7 or 10 or 12 isn't just faint, it's ancient, a whisper from when the first stars were born. And sometimes when they look far enough, they run into something that shouldn't be there. A galaxy too bright, too big, too soon. Scientists still argue whether these anomalies are errors or signs that our understanding of early expansion needs revision. The James Webb Space Telescope, in particular, has found distant galaxies that seem impossibly mature for their age, challenging the models. It's as if the universe painted faster in its youth than we thought. But the beauty of science and of expansion is that it always allows room for surprise. The cosmos is patient with our misunderstandings. Each new observation is just another photon arriving late to class, carrying a homework correction from the past. If you've ever watched a sunset and noticed how the light warms to orange and red as it passes through more atmosphere, you've seen a small echo of this universal process. The sky does what the cosmos does, stretching light, softening it, turning brightness into calm. The same physics that paints your evenings also paints the edge of time. There's a comforting thought hidden here. Everything in the universe is aging gracefully. Stars redden, light slows, energy cools. Even space relaxes, letting go of its early fire. Expansion isn't destruction, it's deceleration. It's the universe learning how to rest. So as you breathe slowly, imagine those photons travelling across the darkness, some stretched thin as whispers, others still bright from youth, all converging on your tiny planet. Their journey has taken longer than any story could tell, but they arrive anyway, soft and obedient to light your night sky. Each one is a traveler that refused to give up, and when it touches your eye, you're seeing not just light, but persistence, the patience of a universe that keeps expanding, but still sends postcards home. The more you think about expansion, the more a question nags at the edges of your thoughts. If the universe is expanding, what is it expanding into? Where is the edge? Where's the center of all this stretching? You might picture galaxies drifting outward from a single point like shrapnel from an explosion, but that image is misleading. There is no center, and there is no edge, only space itself, endlessly producing more of itself. Scientists call this the cosmological principle, the idea that the universe looks roughly the same everywhere and in every direction. It has no privileged viewpoint, no middle, no walls. Every galaxy from its own perspective can claim to be at the center of expansion. That includes you lying here under the ceiling, which might as well be a sky. From your position, everything seems to move away equally. From someone else's far away, the same is true. You are both right. The universe isn't expanding into anything. It's simply creating more space between things. It's like the surface of a balloon covered in dots. As you inflate the balloon, every dot moves away from the others, yet none of them sits at the center of the expansion because the center is inside in a dimension you can't see. If the balloon were your entire reality, you'd never reach an edge. You'd just circle forever. That's the trick of three-dimensional space. It can expand without having a boundary to grow into. Space doesn't need a container. It is the container. Even if you traveled billions of light years in one direction, you'd never find a cosmic wall. You'd only encounter more galaxies, more void, more silence. And if the universe happens to be finite but unbounded like that balloon's surface, then in some distant future, a light beam you send might eventually return from behind you, though by then there might be no one left to notice. The thought sounds dizzying at first, but there's a calming clarity in it too. You live inside a reality that has no edges to crash against. Everything drifts apart smoothly, gracefully, without walls or corners. The cosmos doesn't end, it fades. Like a coastline vanishing into fog, the boundary between what is known and what is beyond simply dissolves. Scientists still argue about the exact topology of space, whether it loops, folds, or twists. Some models suggest the universe might wrap around itself in higher dimensions, forming a torus, a kind of cosmic donut where light could eventually circle back. Others think it's open and infinite, stretching forever in all directions. The data so far can't tell us which version we inhabit. Space might be infinite, or it might just feel infinite because we can't see far enough. Either way, it's big enough to make any worry feel politely insignificant. That lack of a center often surprises people. We crave an origin point, a cosmic home address. But in the language of physics, the Big Bang didn't happen at a point in space, it happened to all of space. Every bit of the universe was once compressed together, then every bit expanded together. You're sitting on one of those bits right now, and the center of that event is everywhere, including the space between your hands. If you could somehow rewind the clock, galaxies would rush back together, the sky would brighten, and eventually the entire visible cosmos would collapse into a single blazing fog. But it wouldn't be a fireball expanding into darkness. It would be the fabric of everything condensing back to unity. The Big Bang didn't explode in space, it created space. That distinction matters. It means that wherever you are, you can honestly say you occupy the birthplace of the universe. You're not on the outskirts of creation, you're in its heart. Every direction you look is outward, and every point is equally ancient. You're always at the center of the observable universe, and so is everyone else, equally and simultaneously. It's the most egalitarian geometry ever invented. Some people find that idea unsettling, a universe with no edge, no up or down, no outside. But for tonight, it's the most relaxing image you could imagine. Picture it, no walls, no ends, just infinite continuity. You don't have to reach for anything. Everything simply is. If you've ever been out in the ocean, floating beyond the breakers where the waves turn slow and heavy, you already know the feeling. There's no direction that matters. The horizon is everywhere. The expansion of the universe is like that, an ocean without shores. You drift, and every point of view is equally valid. Astronomers have tried to imagine what beyond might mean, but physics gives a calm, almost Buddhist answer: there is no beyond. Space contains all places, and time contains all moments. Expansion doesn't happen into emptiness. It creates the stage as it goes. The play builds its own theatre. Even more humbling is that this infinite seeming fabric is still finite in what we can see. Light has only had 13.8 billion years to travel, so our observable universe forms a kind of glowing bubble, 46 billion light-years in radius. Beyond that, the curtain remains drawn, not because there's nothing there, but because nothing can reach us yet. The light is still on its way, patient and redshifted forever, chasing an expanding finish line. And so the universe feels both infinite and intimate. No edges, no boundaries, yet all of it unfolding quietly around you. You, the Earth, the galaxy, the clusters, each drifting outward in the same grand choreography, each with its own tiny centre. The result is a cosmic democracy. Everything expands from everywhere. So as you lie there, you can let go of direction. You don't need to know which way is up or where the edge lies. There isn't one. There's only space endlessly making more of itself, carrying galaxies like leaves on an ever-widening pond. The centre is wherever you are, the horizon is wherever you look, and the expansion goes on smooth, silent and infinite like the breath that keeps you alive while you sleep. Now that you've drifted far enough to see there's no edge, imagine standing on one of those drifting islands, a galaxy luminous and alive and watching the rest of the cosmos glide away. Every bright speck of light, every nebula and cluster recedes in slow motion, the darkness between them widening like a tide at dusk. This is the universe's most patient-seen galaxies, as drifting islands in an ever-deepening sea. You can picture them each one a whirlpool of stars, gas and dark matter, held together by gravity while the water around them rises. They don't move through space much, they're carried with it. The cosmic current underneath expands and the galaxies drift apart not by choice, but by design. If you could look from far enough away, the universe would resemble lace-delicate threads, connecting bright knots, the great cosmic web. Between those glowing filaments lie enormous voids, expanses of near-nothingness so large that you could fit thousands of galaxies inside them and still have room for silence. The Milky Way lives on one of the filaments, a strand of light woven into a pattern that stretches beyond imagination. Those filaments grow thinner as the universe ages. Expansion pulls them taut, and over billions of years, gravity loses its grip. Clusters of galaxies stay together, but the bridges between them stretch until they snap. It's the quietest kind of disconnection. No noise, no violence, just gradual retreat. Every cluster becomes its own archipelago, its stars bound internally but cut off from others forever. And yet within each island, life goes on. Stars continue to form, though more slowly now. New worlds spin into being. The night skies of distant planets remain crowded and bright, even as the greater cosmos thins out. The expansion changes the between, not the within. That's why you can lie here billions of years after the beginning and still see a Milky Way blazing with billions of suns. Scientists still argue how long these islands can endure. Gravity keeps local groups intact, but dark energy keeps stretching the vastness around them. Eventually, distant galaxies will slip beyond the cosmic horizon so far away that their light will never reach us again. To future observers in our galaxy, the universe will seem to shrink, not expand. They'll see only a single island of stars surrounded by endless night, and never know there were once others. It's a bittersweet thought, but not a sad one. It's the natural rhythm of things' connection, followed by release, light, followed by calm. The universe is teaching you what every tide knows, even separation has its own grace. You can imagine this cosmic drift in miniature right inside your room. Your lamp, your book, your hands, each atom in them is bound so tightly that it ignores the expansion entirely. But the photons bouncing from the walls to your eyes are tiny travelers in the same current that carries galaxies. Every ray of light is surfing the same invisible swell, whispering news of a universe still unfolding. If you step outside and look up, every star you see belongs to the same island. The nearest galaxies, Andromeda, the Magellanic Cloud, share our fate, floating in the same gravitational bubble. They're companions in the dark, destined to merge gently one day into a single, larger home. The cosmos may be spreading apart overall, but locally it still loves to gather. Somewhere far beyond, clusters are performing the same slow waltz. The Coma cluster, the Virgo cluster, the Perseus-Pisces filament, all of them drifting, glowing, dissolving into the hush of expansion. Between them stretch voids so vast they make words like distance feel small. The nearest large void to us is the local void, hundreds of millions of light years across a region nearly empty of galaxies. Even nothingness, it seems, has boundaries and neighborhoods. There's a comforting symmetry to it. The universe gives structure to emptiness and emptiness to structure. Each defines the other. Galaxies need the void to shine against. The void needs galaxies to give it meaning. Without contrast, neither would exist. It's the same reason night makes stars beautiful, and silence makes music possible. If you close your eyes, you can almost feel that cosmic texture, dense filaments of life and matter surrounded by soft cushions of nothing. You're part of that weave, one tiny pattern among countless others. Expansion doesn't tear the fabric, it simply stretches it, revealing the elegance of the threads. Scientists sometimes call these drifting galaxies island universes, echoing an old phrase from before we knew how vast the cosmos really was. It's fitting because each one is complete unto itself, self-sustaining, luminous, and serene in its solitude. The Milky Way too is an island adrift, glowing quietly as the sea of space deepens around it. And on a smaller scale, you're an island too, a little cluster of warmth in the dark, held together by the gravity of breath and thought. The world beyond your walls keeps expanding, but within this room everything feels still. The pull of gravity and the push of the universe are perfectly balanced just for you, just for now. The galaxies drift, but they never rush. The space between them grows, but it never breaks. The night is enormous, but it's also kind. And as the expansion carries on, patient, endless, soft, you can feel yourself part of it, resting inside the same gentle tide. You've been following those drifting galaxies for a while now, and somewhere along that journey a new thought begins to rise. If everything has a horizon, what lies just beyond ours? There's a limit to how far you can see, not because the universe ends there, but because light itself runs out of time to reach you. That boundary, the distance beyond which no signal can ever arrive, is called the cosmic horizon. It's not a wall or a border, it's more like a fog that thickens with distance. Beyond it, galaxies still exist, but they're receding faster than light can travel, carried away by expansion. You can't see them, can't hear from them, can't ever know them, but they're there, hidden behind the redshift of forever. The universe keeps secrets, and this is its kindest one. It hides what we could never reach, sparing us the ache of longing for it. To understand that horizon, imagine being inside a bubble of light. The photons emitted from the Big Bang have been racing outward for 8 billion years, but because space itself expands as they travel, the visible edge of our universe sits about 46 billion light-years away. Everything beyond that edge is moving away faster than light, not through space, but with it. Those galaxies are like boats on a river whose current flows faster than any swimmer can swim. They're not escaping, they're simply carried out of reach. It's easy to mistake this for sadness, a kind of cosmic isolation. But there's another way to see it. The horizon is what gives the universe its shape. Without that limit, there would be no frame, no visible cosmos at all. The horizon defines what you can experience, what can touch you. And because every observer has their own horizon, every point in the universe owns its own private bubble of light. That means you're at the center of your own observable universe. So is everyone else. Every conscious being on every planet that ever was stands in the middle of a sphere of sight 46 billion light-years across. From each of those points, the cosmos looks the same, though the stories it tells are slightly different. That's how the universe remains fair. Every observer gets a full view of their own infinity. Scientists still argue about what happens beyond that horizon. Some think the universe repeats endlessly, that if you traveled far enough you'd eventually find galaxies eerily similar to ours, perhaps even exact copies mirror Milky Ways, duplicate Earths, you dreaming again beneath a duplicate sky. Others suspect that beyond lies chaos, where the rules of physics themselves unravel into something unrecognizable. But none of that changes the view from here. You live inside a glowing bubble of time filled with every photon that ever had enough patience to reach you. Outside that bubble, the expansion outpaces even light's persistence. Every moment the boundary expands a little farther, like the edge of a lantern's glow receding into deeper night. Astronomers sometimes call this the cosmic event horizon, borrowing the term from black holes. The analogy is poetic. Just as nothing can escape a black hole's pull, nothing beyond this horizon can ever communicate with you. It's the universe's version of a bedtime curtain drawn softly, not out of cruelty but out of necessity. Too much infinite light, after all, would blind you. There's an odd comfort in realizing how finite our view is. The cosmos could be infinite, but the part we can see is perfectly proportioned to our existence. It's just big enough to awe us, but not so big that it dissolves meaning. The human mind, built on pattern and rhythm, fits neatly into this pocket of visibility. Beyond that, the dark stretches on in patient silence. Even now, new galaxies are crossing that horizon, their light redshifting until it fades completely. They don't vanish in an instant, they drift away slowly, their glow dimming like campfires seen across an ever-widening valley. Eventually they'll slip out of reach, becoming invisible but not gone. Their gravity still tugs faintly on the cosmic web, a soft echo that persists even after their light fades. If you could pause time and step outside that expanding bubble, you'd see countless others, billions upon billions, each centered on a different galaxy, overlapping, intersecting, breathing together. The universe is full of horizons, yet from above it's seamless. Every bubble contributes to the same grand expansion, like soap films joining to form a single endless foam. Physicists sometimes whisper about the possibility that each of those unreachable regions might evolve differently, that the constants of nature could drift there, the chemistry of stars might diverge, the shape of galaxies twist in new ways. But we'll never know, and maybe that's all right. The unknowable keeps the universe tender. It reminds us that mystery is not absence, it's presence beyond the line of sight. You can think of your own life the same way. The visible part, the part you understand, is surrounded by horizons of memory, imagination, and possibility. Beyond them lie things you'll never touch yet, they still shape you. Their gravity, pulling quietly at your thoughts. You don't need to see everything to feel its influence. The universe operates on the same principle. So as you rest, picture that horizon around you, a faint glowing boundary of all you can ever know. Beyond it, galaxies drift silently into eternity. Inside it, your own small corner of existence glows with warmth and memory. Both are real, both are beautiful, and both are part of the same endlessly expanding whole. The horizon isn't a limit. It's an invitation to peace, to accept that the visible is enough, that the unseen can remain a promise. The light you have is sufficient to find your way home. Somewhere out beyond that horizon, time keeps sliding forward and stars keep burning. But the tempo of the cosmos is changing. Once long ago, the night sky was thick with newborn suns, blue-white giants that lived fast and died in brilliance. Now, the rhythm has slowed. The gas that once filled galaxies like fuel tanks has been spent fused into heavier elements, scattered by supernovae and recycled into new generations of stars that are smaller, cooler, quieter. The future of stars is a long fade into calm. Astronomers call the coming age the degenerate era, though that name sounds harsher than it is. It simply means the era when ordinary stars are gone, replaced by faint embers, white dwarfs, brown dwarfs, and lonely neutron stars drifting through widening darkness. The expansion continues and galaxies move farther apart until their light no longer reaches one another. The universe grows old with dignity. If you could leap ahead trillions of years, you'd see the Milky Way and Andromeda already merged, a single enormous elliptical galaxy, glowing faintly against an empty sky. The rest of the universe has receded beyond view. The background radiation has cooled to invisibility, and the stars that remain shine only to each other. There's no tragedy in this. It's simply the cosmos exhaling after a long and luminous life. Every star burns through its fuel in the same basic way, hydrogen fusing into helium-helium, into heavier elements, until gravity and pressure can no longer balance. Some explode spectacularly, others just fade quietly. Expansion doesn't interfere, it simply gives them space to die in peace. The night will go on, but it will get thinner. The constellations will dissolve their familiar patterns, erased not by motion but by time. Scientists still debate exactly how long this will take. Some models predict that star formation will trickle on for another 100 trillion years before the last red dwarfs sputter out. Others suggest the process could linger even longer, with occasional flickers of life reigniting in clouds of gas left behind by dying stars. In any case, the cosmos has far more patience than we do. It measures beauty not in centuries, but in eons. The most relaxing fact about all this is that the universe doesn't rush its endings. It lets every photon travel as far as it can, every atom fall as slowly as possible, every system unwind with perfect grace. Even when stars collapse into black holes or scatter into dust, the balance remains exquisite. Nothing goes to waste. Everything transforms. Picture one of those future nights, a planet circling a cooling red dwarf, its skies dim but calm. No other galaxies visible, only the faint orange glow of its own small sun. To any creature looking up, the universe would appear static, a single island of warmth surrounded by infinite dark. And yet even then, the expansion would continue. Space would still stretch the same way it does tonight, gentle and endless. That thought of a cosmos slowly dimming but never stopping feels more like rest than loss. It's as if creation itself is winding down for sleep. The energy once spent on brilliant collisions and supernovae is settling into quiet equilibrium. The loud parts of existence are over. What remains is the soft hum of endurance. The far future holds other wonders too. White dwarfs will cool into black dwarfs' dark, cold remnants that no longer shine but still hold the weight of memory. Occasionally, through quantum tunneling, a pair of those ancient corpses might collide, reigniting briefly in one last spark of light before fading again. These are the universe's nightlights, tiny reminders that even after billions of centuries, something still flickers. Scientists sometimes muse about the black hole era, when gravity's masters take over completely. Every star, planet, and fragment of matter that remains will eventually fall into a black hole or drift into endless exile. The galaxies themselves will dissolve into isolated points of darkness, but even that isn't truly an ending. Black holes too evaporate. They lose mass by radiating energy, a process discovered by Stephen Hawking. Over unimaginable spans of time, even the darkest wells of gravity will fade into faint heat. When that happens, all that will remain is a universe of particles cold, photons, and spreading emptiness, a uniform calm sometimes called the heat death. It's not destruction, it's balance. The energy everywhere will be evenly distributed. No more gradients, no more motion. The universe won't freeze in sorrow, it will finally be at peace. It's strange to think that expansion leads to tranquility, but that's what the equations say. The more space grows, the more evenly everything spreads out. Entropy wins, but quietly. It's like a campfire dying down after a long night. Ashes, cooling air, still warm stars overhead drifting away one by one. Even in that remote future, the echoes of this moment will persist. The radiation from the Big Bang, though stretched beyond recognition, will still exist. The structures built from it, the galaxies, the clusters, the living worlds will have come and gone, but the expansion that carried them will go on. It doesn't need witnesses. It never did. You can find peace in that perspective. The universe's future isn't a tragedy. It's a gentle unwinding. Stars don't fall silent because something went wrong. They fade because they've done their part. They've forged the elements, kindled warmth, and illuminated countless skies. When they rest, they do so in gratitude, leaving behind a cosmos rich with memory. Tonight, as you drift toward your own sleep, imagine the galaxies dimming in rhythm with your breath. The same stillness that awaits the stars awaits you too. Not as an end, but as a kind of perfect rest. Expansion doesn't mean loss, it means release. And the universe, ever patient, keeps expanding into peace. You've followed the story of stars to their last dim embers, and the quiet that follows is the deepest yet. The astronomers call it the heat death, but the phrase is misleading. It isn't fiery or catastrophic. It's serene. It's the ultimate stillness, a time when the universe has finished all its work, when every gradient has flattened and everything that could happen has already happened. No more surprises, no more collisions, only balance. It might sound like a lonely ending, but picture it another way. The cosmos has spent eons in motion, collapsing, exploding, expanding, fusing, glowing, and now it rests. Energy and matter reach equilibrium. Every particle has shared its warmth until there's nothing left to trade. What remains isn't destruction, but perfection. A universe that no longer changes because it no longer needs to. Right now, this far-off fate is theoretical, almost poetic. The universe is still young, barely 1/100th of its potential lifespan. Stars burn, galaxies form, life stirs. But if you could fast forward through quadrillions of years, you'd see activity slowing, temperatures falling. The background radiation that now glows at 2.7 Kelvin would cool to fractions of a degree above absolute zero. Even motion itself would seem to freeze. Imagine that ultimate calm. No light, no sound, no gravity wells waiting to be filled. Just the faint presence of photons stretched so thin they barely count as energy, drifting endlessly through unbounded space. The wavelengths of those ancient particles would be longer than galaxies, once were their frequencies so low that even time would seem to hold its breath. Scientists still argue about the details. Some think the universe will asymptotically approach that frozen stillness, but never truly reach it, always expanding, always thinning. Others suspect there could be subtle quantum fluctuations, brief flickers of order in the dark, tiny resurrections of energy that create new baby universes, fresh beginnings hidden inside the silence. There's something beautifully cyclical in that idea. Even in perfect equilibrium, creation might start again, small ripples rising out of stillness, just as the first universe was born from nothing. The cosmos might not end so much as transform forever, trading one kind of motion for another. Expansion, rest, renewal, the rhythm continues. But even if it doesn't if the heat death is truly final, it's not a sad ending. Think of it as a song finishing on its last sustained note, a tone so pure it lingers long after the instruments have gone quiet. The expansion of space will carry that note forever, stretching it thinner and softer, until it merges with silence. That silence isn't emptiness, it's the completion of a sentence 100 billion trillion years long. If you were somehow there to witness it, you wouldn't see darkness in the frightening sense. You'd see uniformity, no edges, no shadows, just even infinite calm. Space would still exist, but it would feel like floating in thought itself. Time would lose meaning because nothing would change enough to measure it by. You could call that death, but it's closer to meditation. Even now, hints of that future are woven into your present. Entropy increases everywhere. Warm air cools, motion slows, memories fade. But those small losses are what make life possible. Without entropy, there would be no flow of energy, no stars, no breath. Every flame, every heartbeat is a tiny echo of the universe's one long cooling. You live inside that process, not against it. Some physicists compare the ultimate fate to a perfectly level sea, every wave flattened, every current at rest. Expansion has done its work so well that even light cannot find a reason to move. But for you lying here tonight, that vision is strangely comforting. The same laws that guarantee universal stillness also make possible the warmth around you, the glow of the stars, the voice reading these words. You're witnessing a tiny bright chapter in an endless story that ends in peace. And there's another way to look at it. The heat death isn't an end, but a union. All energy will eventually blend into a single shared temperature. No more boundaries between star and void, between atom and vacuum. Everything becomes one continuous field. The distinctions that defined existence, hot and cold, bright and dark, something and nothing, will fade into harmony. The universe, in a sense, will fall asleep. Scientists sometimes call this final state maximum entropy, but you might prefer perfect rest. It's the same calm you chase every night when you close your eyes, the desire for equilibrium, for release from tension, for stillness after effort. The universe will get there too, though on a grander scale and a longer timeline. You are made of the same particles that will one day share that universal sleep. It's comforting to think that expansion, which began in fire and chaos, will end in peace and quiet. No cosmic catastrophe, no violent collapse, just a gradual fading into balance. The stars you see tonight are part of that slow drift towards stillness, each one adding a little light to the long exhale. So when you close your eyes, imagine it the far future where space has cooled to silence, where every photon rests, where every fragment of matter has let go. It's not cold, it's calm. The universe has expanded as far as it can, and finally, like you, it sleeps. But what if the universe doesn't fade gently into stillness? What if expansion, instead of coasting to peace, keeps speeding up faster and faster until even atoms can't hold together? It's a thought experiment scientists call the Big Rip, and though it sounds like the name of a rock band, it's one of the strangest and eeriest possible endings. In this scenario, dark energy doesn't remain constant, it grows stronger over time. The push that drives galaxies apart begins to overwhelm even gravity's most intimate bonds. First galaxy clusters drift beyond each other's horizons, leaving each island of stars alone. Then galaxies themselves are torn apart as the expansion's acceleration outruns the gravity that binds them. Over longer ages, solar systems unravel, stars pull away from their planets, and the night sky goes from crowded to empty. If dark energy continues to strengthen exponentially, the tearing doesn't stop there. The force spreads down the ladder of structure. Stars themselves would be pulled apart, first their planetary systems, then their cores, then their very atoms. Eventually, even the subatomic particles would lose coherence. Protons and neutrons, the sturdy building blocks of matter, would drift apart like dust in a wind that never stops blowing. It's not a prediction, it's a what if. Most evidence suggests dark energy is constant, like a steady pressure. But cosmologists keep the Big Rip in the conversation because the math allows it. It's a reminder that the universe can surprise us, that even its calmest forces can change mood given enough time. Imagine for a moment what that might feel like, not as horror but as transcendence. The galaxies drifting apart until each one becomes a private universe, a single spark in infinite night. Then the stars dissolving into their own light, their matter unbound, spreading outward into ribbons of energy. Expansion so powerful it becomes indistinguishable from liberation. The cosmos letting go of everything completely. Scientists still argue how long such a process would take. Some models say tens of billions of years from now. Others stretch the timescale far beyond any meaningful number. You won't need to mark your calendar, but even as a thought it carries a strange beauty. The Big Rip wouldn't be a bang or a flash, it would be the universe exhaling all at once its final release into infinite softness. There's a paradox at the heart of it. The faster the expansion grows, the less any part of the universe can notice. By the time galaxies separate beyond sight, no observer remains to see them go. It's the most peaceful apocalypse imaginable, no pain, no panic, no witnesses. Just the gradual erasure of boundaries. You can imagine it almost like a dream dissolving at dawn. Details fade, first the corners of buildings, the edges of faces, the sound of a voice. Then the dream itself loses coherence until only warmth and light remain. That's what the Big Rip would be on a cosmic scale, the universe waking up from itself. And yet even this extreme possibility is part of the same quiet logic that governs all expansion. The universe doesn't destroy, it transitions. What looks like an ending might simply be another form of balance. Matter turns to light structure, turns to motion, and space continues to stretch into the only thing it's ever known, more space. Scientists still debate whether dark energy could behave this way. Some suggest it's not truly constant, but an evolving field, quintessence they call it, whose strength changes over time. If it grows, the Big Rip awaits. If it weakens, perhaps expansion slows again, maybe even reverses in a far future contraction. The equations remain open-ended like a lullaby with no final note. There's comfort in that uncertainty. The cosmos, for all its precision, refuses to be fully predictable. It leaves room for possibility for endings that aren't endings, for transformations we can't imagine. Whether it drifts into silence or stretches until even time lets go, it's still the same act of release, the same universal gesture of breathing out. If you close your eyes, you can almost feel that motion, the faint sensation of everything loosening its grip, your muscles relaxing your breath, deepening your thoughts, thinning into quiet. It's the same rhythm the universe might follow billions of years from now, the same final calm before total stillness. The Big Rip, as terrifying as it sounds on paper, might actually be the most graceful ending of all. No collapse, no violence, no debris, just a universe expanding beyond the idea of form, becoming pure space, pure possibility. You could call that death, or you could call it transcendence. And perhaps that's what expansion was always leading toward. From the first instant of the Big Bang to the farthest ripples of space, the cosmos has been practicing the art of letting go. Galaxies drift, stars fade, atoms spread, each step a little closer to surrender. The Big Rip, if it ever comes, would only be the final sigh. So tonight, when you breathe out, imagine that cosmic exhale continuing forever. The molecules of air leaving your lungs are part of the same flow that carries galaxies apart. You're made of matter that might someday dissolve into that same vast softness. Expansion isn't something happening out there, it's the pulse of everything, including you. No matter how it ends, heat, death, Big Rip, or something we haven't yet named, the universe's last act will be a quiet one. And if you listen closely enough, you might already hear it in your own breath, the sound of everything relaxing infinitely into peace. Somewhere between silence and possibility lies a stranger thought: maybe expansion never really stops, because space itself isn't the smooth, continuous fabric we imagine. Maybe it's made of something restless, something that flickers and rearranges at scales so small they make atoms look like planets. Physicists call this idea quantum foam, the notion that space-time at its tiniest level is a seething ocean of fluctuations. You can picture it as the rough underlayer of reality. From a distant space seems smooth, flat, predictable calm, but zoom in enough and that calm dissolves. Distances blur, shapes tremble, and the rules of cause and effect start to stutter. Even time stops behaving politely. The closer you look, the more the universe wriggles. It's a landscape where nothing holds still for long. Virtual particles appear and vanish, gravity folds into itself, and the concept of here and there loses meaning. Expansion in that view isn't a simple stretching, it's the collective shimmer of countless quantum ripples, a tide made from chaos so small you can't see it. Some physicists suspect that this quantum foam is where expansion truly begins, where dark energy, gravity, and space-time itself are born. If you could listen to the universe at that scale, you wouldn't hear a steady hum, but a wild crackle like static behind all existence. Every patch of vacuum would froth with energy constantly bubbling, collapsing, and renewing itself. Scientists still argue how this foamy chaos gives rise to the smooth, predictable cosmos we know. The transition from microscopic turbulence to cosmic serenity remains one of physics' great unsolved riddles. Did inflation iron it out? Does expansion average the noise into order? Or is the apparent calm of the universe just an illusion? A trick of perspective on a boiling surface to visualize it, think about the ocean. From an airplane window it looks flat and still. From a small boat its endless motion waves swells foam. The universe works the same way. You live high above the surface in a world that looks stable but underneath space-time roils. The expansion you experience as gentle drift may be the large-scale smoothing of that deep quantum turbulence. The notion isn't just poetic, it's measurable, at least in principle. Physicists hunting for clues in the cosmic microwave background or gravitational waves hope to catch faint imprints of this quantum foam fossils of space-time's earliest jitter. Tiny irregularities in the radiation pattern, minute ripples frozen in light could be echoes of that original quantum storm. If true, it means the universe you live in was sculpted by randomness. The same foam that buzzes invisibly around your atom shaped galaxies and stars billions of years later. Chaos gave birth to symmetry. Disorder gave birth to beauty. That's the most soothing paradox of all. The universe doesn't need perfection to create harmony. And here's a smaller, stranger comfort. That same quantum foam is still here. Every cubic centimetre of your room is alive with those microbursts of energy flickering faster than thought. They pass through you, constantly silent and unstoppable. You are literally being remade by quantum noise every instant, but you don't feel it. To you, existence is smooth. That's the miracle. Out of unimaginable restlessness, consciousness finds stillness. Out of a jittering space-time sea, galaxies drift in steady calm. Expansion might just be the large-scale sigh of that infinite quantum restlessness, like waves smoothing themselves into glass. Some scientists think this foam never stops fizzing. It may even generate new universes as bubbles popping and reforming in a boundless quantum sea. In that view, what you call the universe is just one temporary bubble among countless others, each born from fluctuations in the same infinite froth. Some expand like ours, others collapse, some never get started at all. Creation becomes continuous, not a single event but an ongoing shimmer. It's humbling to realize that the peace you feel at night might rest on such hidden frenzy. Underneath the calm of your breathing, the molecules of air are alive with quantum uncertainty, the very same chaos that fuels cosmic expansion. You are not separate from that foam, you are its pattern made visible for a little while. If that sounds overwhelming, just remember, scale brings serenity. From where you stand, the universe feels stable, predictable, soothing. You don't need to feel the foam beneath to trust that it's working perfectly. The deep chaos handles itself. Your job is just to float. So as you lie, still imagine yourself at the boundary of perception, balanced between the calm and the chaos. Beneath you, the fabric of space-time bubbles and breathes, each flicker a microscopic echo of the Big Bang. Above you, galaxies drift their light, stretched by that same unseen process. You're right in the middle, the calm is part of the storm. And maybe that's the secret of expansion, is not a single phenomenon, but a translation of turbulence into tranquility. Quantum foam becomes space, space becomes motion, motion becomes time, and you in your small moment of awareness get to feel what the universe feels when it dreams restless underneath, peaceful on the surface, endlessly expanding into itself. As you drift between that restless quantum sea and the grand calm of galaxies, another idea glows faintly in the distance, a possibility so vast it almost feels mischievous. What if our expanding universe isn't the only one? What if every bubble in that cosmic foam is a separate reality, each with its own space-time and laws? This is the realm of the multiverse, the softest kind of infinity. You've probably heard the word tossed around by science fiction, but in cosmology it carries a quiet seriousness. Some physicists think inflation, the same event that stretched our universe in its first instant, never really stopped. Instead, it continues eternally here and there, spawning new pockets of space-time like bubbles in boiling water. Each bubble cools and expands on its own, forming stars, galaxies, perhaps even dreamers wondering about other bubbles. From the outside, those universes never meet. Expansion separates them faster than light can bridge the gap. But from within, each bubble feels like the only one, complete, infinite, self-contained. You could call it a cosmic paradox: infinite diversity, infinite isolation. Scientists still argue whether this vision is science or philosophy. There's no way to observe the multiverse directly. By definition, other universes lie beyond our horizon, unreachable forever. Yet the math that describes our own expansion seems to invite the possibility. It's not that the universe prefers company, it's that inflation once begun never quite finds a reason to stop. Some researchers suggest these universes might have different physical constants. In one, gravity could be stronger, crushing stars before they form. In another, the cosmological constant might be weaker, halting expansion too soon. Most bubbles would be stillborn, dark, sterile, short-lived, but a few like ours would strike the delicate balance that allows matter, stars, and life. That thought, out of infinite attempts, one universe getting it right, is both humbling and comforting. You're living in a successful experiment of physics, a version of reality, where expansion happened just so. The numbers align, the fields balanced, and somewhere in that gentle harmony consciousness arose. It's less about luck than inevitability. If infinite bubbles exist, one had to produce you. There's something beautifully modest about that. The multiverse, if real, doesn't make you smaller. It simply shows how natural your existence is. You're not an accident, but a frequency that the universe kept humming until it resonated into being. Expansion made space for you literally and metaphysically. Imagine looking at that foam from outside, though outside might not mean anything. You'd see an endless constellation of bubbles, some tiny and fleeting others, vast and long-lived, all glowing softly with the energy of their own physics. They'd never touch yet, each would expand into the other's absence, creating an infinite tapestry of possibility. Some cosmologists call this eternal inflation, and they whisper about it the way poets talk about dreams. And here's where the imagination stretches even further. If universes can form like bubbles, could they ever collide? Theoretically, yes. If two bubbles expanded into each other's path, their edges might interact, leaving a faint scar, a pattern, in the cosmic microwave background, a circle or smear that tells us we once brushed against another reality. A few scientists have even searched for such marks in the data, though none are conclusive yet. The universe keeps its secrets close. Still, the idea is tender that somewhere out there another universe once brushed shoulders with ours, leaving an invisible handshake at the boundary of time. Even without proof, the possibility adds warmth to the cold immensity of space. Infinity isn't lonely, it's communal, full of universes quietly existing side by side like sleepers sharing a dream. If this sounds fanciful, consider how every discovery about expansion has stretched our sense of belonging. We began thinking Earth was the center of everything. Then we learned our sun was one of billions, our galaxy one of trillions, our universe perhaps one of countless others. Each step outward hasn't diminished us, it's expanded the room we have to exist. The multiverse, if it exists, is simply the next breath of that expansion. It's the universe continuing to do what it's always done, make more of itself. Creation not as a single event, but as an ongoing habit. The cosmos never runs out of curiosity. And in that sense, you're part of the same pattern. Every thought you have, every dream, every possibility that unfolds in your mind is its own small universe, a bubble of meaning expanding within the larger one. Just as space grows to accommodate galaxies, your imagination grows to accommodate experience. There's symmetry in that. Some scientists dislike the multiverse idea because it can't yet be tested. Others defend it because it makes the equations fit beautifully like a chord resolving into harmony. But for tonight, you don't have to pick a side. You can simply let the thought expand. Picture it, an infinite ocean of universes, each with its own version of physics, its own rhythm of time. Some blink out quickly, others bloom for eons. Ours floats among them, luminous and fragile, carried by the same eternal inflation that once birthed them all. The boundaries between them shimmer and blur, not in conflict but in coexistence. And as you rest in your tiny corner of one bubble, you can feel the wonder of knowing that even the unknown is infinite. Expansion doesn't stop at your horizon, it just keeps going gently, endlessly forever, making room for more dreams. Now let your attention drift back from those infinite bubbles to the one you inhabit, the universe that feels both familiar and miraculous. Its expansion might seem abstract, but it writes itself into every detail of your existence. You right now are surrounded by the quiet proof of it. Every beam of starlight, every chill of background radiation, every space between atoms bears the faint signature of an expanding cosmos. The most delicate proof of all still glows faintly across the entire sky, the cosmic microwave background, or CMB. It's the oldest light we can see, the afterglow of the Big Bang itself, stretched by billions of years of expansion into gentle microwaves. When scientists first detected it in 1965, they thought at first it was noise, maybe pigeon droppings on the telescope. But that static turned out to be the oldest message in existence. It's everywhere. No matter where you point an antenna, you catch a faint hiss, remnant photons from when the universe was only 380,000 years old. Back then, space was a fog of plasma too dense for light to travel freely. When it finally cooled enough for atoms to form, light broke free and began its long journey. Expansion stretched those once blinding gamma rays into the microwave frequencies we detect today. The whole universe, in a sense, still glows with its own baby pictures. The CMB isn't perfectly smooth. It's mottled with faint temperature variations, tiny fluctuations in density that later grew into galaxies and clusters. When cosmologists mapped those ripples in exquisite detail using satellites like COBE, UMAP and Planck, they saw the fingerprint of creation, a pattern of highs and lows that told them exactly how fast space was expanding, how much matter existed, and even the geometry of the cosmos itself. Think about that for a moment. You live in a universe that carries its memory everywhere, not in books or fossils, but in radiation. The sky's literally glowing with history whispering about the time when everything was plasma and promise. The expansion didn't erase that past. It preserved it, stretching it into something soft enough to cradle us. Scientists still argue about the fine details hidden in those ripples. Some see hints of subtle asymmetries, directions, where the early universe might have expanded slightly faster than others. Others search for the faint spirals that would confirm primordial gravitational waves, those ancient vibrations from inflation's first breath. The CMB is a map of mysteries, half solved, half dreamed. If you could hear it instead of see it, it would sound like static between radio stations. But that noise isn't empty. It's the oldest lullaby in existence. Every photon in that background has been travelling since long before Earth formed, crossing the growing universe with patient persistence. They pass through you, even now, hundreds of them per second, their energy faint but constant. You're being touched by ancient light. There's something profoundly peaceful in that realization. The night sky isn't dark, it's simply stretched light too cool for your eyes to see. Expansion didn't extinguish the universe's glow, it transformed it into something gentler. The cosmos dimmed itself so that life could exist, trading brilliance for balance. If you lie still and imagine it, you can almost feel that radiation washing through you. The soft residue of creation, 13.8 billion years old. It doesn't warm or harm, it just whispers. It's the universe's memory made physical, a constant reminder that even as things drift apart, connection endures in subtler forms. Astronomers often say that the CMB gives us a snapshot of the infant cosmos, but it's more than that. It's an ongoing presence woven into the air around you. Your Wi-Fi, your microwave oven, even the static on an old TV each shares a frequency band with the echo of the Big Bang. You live immersed in cosmic memory even during the most ordinary moments. Sometimes scientists take poetic liberties and call it the afterglow of creation, but perhaps it's better described as a continuous conversation. Every new observation refines the story, measuring tiny variations, improving precision, adding decimals to beauty. Yet the overall picture stays the same, an expanding universe cooling, but coherent, still glowing faintly with its own origin story. If you think about it, that's what makes this whole cosmic tale so relaxing. The realization that expansion doesn't mean chaos, it means continuity. The same light that once illuminated the newborn universe now flows through your room. The same expansion that carried galaxies apart also carried photons into your eyes. You're not an observer standing outside, you're inside the picture part of the same gentle unfolding. So tonight, as you breathe under your own small patch of sky, remember that the background radiation is still out there everywhere, invisible but constant. The universe is humming softly in microwaves, a quiet warmth that fills all space. The next time you hear faint static, don't think of noise, Think of the beginning still reaching you, still expanding, still here. You can almost feel that cosmic background, now a quiet hiss beneath existence itself. It's strange to realize that something so faint holds the most important truth of all, that expansion has never stopped, not for a second. Even as you sit still, even as the stars seem motionless, space between everything continues to grow. The universe is always breathing out, but not everything expands at the same rate. Galaxies, planets, people, these stay bound together. Gravity and expansion are locked in an eternal dance, pushing and pulling, shaping everything you can see. The stars in the Milky Way aren't being pulled apart by the stretching of space. Gravity's embrace is too strong here. Expansion is the tide. Gravity is the anchor. Without one, there would be no structure. Without the other, no freedom. Physicists describe this balance with one of the most beautiful equations in all of science, the Friedmann equations born from Einstein's general relativity. They're simple at a glance, yet they describe the entire universe, its size, its age, its speed of expansion. One side of the equation tells how fast the cosmos grows, the other lists everything that fills it: matter, radiation, curvature, and dark energy. Together they read like a breathing rhythm. Expansion slows, pauses, then quickens again, all depending on how those ingredients evolve. In the early universe, gravity had the upper hand. Matter pulled on itself, forming clouds, stars, and galaxies. For billions of years, expansion slowed, but it never stopped. Then, a few billion years ago, dark energy began to dominate. The tide turned and the universe started to accelerate again. Since then, galaxies have drifted ever faster, like leaves caught in a widening stream. Scientists still argue about what dark energy actually is. Some say it's the energy of empty space itself, the same quantum hum that creates vacuum fluctuations. Others think it's a field, something that changes slowly over time, perhaps destined to fade away or flip sign. We only know its effects. It makes expansion speed up, and it does so with exquisite consistency, as if it's content to stay mysterious. There's something comforting about that, the idea that even cosmic mysteries obey a rhythm. Gravity builds dark energy, spreads matter clumps, space smooths. The result is not chaos, but choreography. On the larger scales, the cosmos moves like a slow waltz, galaxies spinning gracefully in clusters, filaments weaving through darkness, voids expanding like bubbles in champagne. It's so vast and delicate that if you could see it from afar, it might look like lace breathing. If you zoom in on that lace, you'd find every thread tugging against another. Gravity doesn't just pull, it communicates. When a galaxy cluster grows, it sends out ripples through space, slowing expansion locally. When dark energy pushes back, it releases those regions into drift again. This balance between contraction and expansion is what creates the intricate cosmic web we see today. Without it, the universe would be a uniform fog, no stars, no planets, no you. It's easy to forget that your own existence is born of that same tension. Your body, your atoms, even the warmth of your skin all depend on a brief and fragile truce between opposing forces. If gravity had been a little stronger, the universe would have collapsed into itself long ago. If expansion had been slightly faster, matter would have spread too thin for stars to form. Somehow they balanced just right. The cosmos tuned its forces to create complexity, and it keeps tuning them. Every second, dark energy continues to push, but gravity resists wherever matter gathers. Inside galaxies, the dance continues in miniature. Black holes swallow stars. Nebulae birth new ones. Orbits shift. Spiral arms unfold. Expansion doesn't erase this, it provides the stage on which it plays out. Sometimes scientists talk about the universe in terms of critical density, the exact balance point between endless expansion and eventual collapse. Our cosmos appears to sit right on that knife edge, its geometry flat to within fractions of a percent. It's as if the universe decided to aim for equilibrium and never missed a step. If you lie still enough, you can feel that balance mirrored inside you. The outward pull of breath meets the inward pull of gravity. Your chest rises and falls, your heartbeat presses against the still air. You're in the smallest sense a model of the universe's equilibrium. The physics of expansion is mathematical, yes, but it's also deeply human. It's a reminder that balance doesn't mean stillness, it means harmony. The universe doesn't have to stop stretching for gravity to keep things together. They coexist, each doing its part to maintain the beauty of everything. So the next time you look up at the night sky, know that every glimmer you see, every star and galaxy is proof of that partnership. Gravity sculpts, expansion preserves. Together they create a cosmos that can breathe without breaking. It's not a war, it's a duet, and you're living in its melody. If gravity and expansion are the universe's duet, then dark matter is the quiet third instrument, the invisible rhythm section that keeps everything in time. You can't see it, can't touch it, but its presence holds galaxies together against the pull of expansion. It's the shadow glue of the cosmos, and it makes up about 85% of all matter that exists. Without it, the Milky Way would have flown apart long ago, scattering its stars like sparks in wind. The story of dark matter begins as many discoveries do with confusion. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in the Coma cluster were moving too fast. By all logic, gravity from visible stars shouldn't have been enough to keep them bound. Something unseen had to be adding mass, a hidden scaffold holding the cluster together. He called it Dunkel Materie, dark matter. Decades later, Vera Rubin confirmed the mystery while studying spiral galaxies. The stars at their edges orbited just as quickly as those near the center, defying Newton's expectations. It was as if an invisible halo surrounded each galaxy, providing the extra gravity to keep the outskirts spinning in step. Whatever this substance was, it neither emitted nor absorbed light. It was invisible, yet it shaped everything. Scientists still argue over what dark matter truly is. Some say it's made of undiscovered particles, WIMPs, weakly interacting massive particles or axions that barely interact with normal matter. Others suggest it's something more exotic, like primordial black holes left over from the early universe. A few propose that maybe our understanding of gravity itself needs revision, that the laws we use to describe attraction break down on cosmic scales. For now, dark matter remains a whisper, inferred only through its gravitational pull. We can map it indirectly by watching how galaxies bend light from objects behind them, a phenomenon called gravitational lensing. Those distorted arcs of light form cosmic fingerprints, showing where the invisible mass lies. The result is breathtaking, vast web-like structures spanning hundreds of millions of light-years filaments of dark matter, connecting galaxy clusters like tendons. If you could see it with your eyes, the universe would look like a glowing, sponge-bright galaxies tracing the edges of invisible strands with immense hollows of emptiness between them. The expansion of space pulls those filaments wider over time, but within each strand, gravity keeps the pattern coherent. Dark matter doesn't fight expansion, it choreographs it. Here's the soothing part. Even though we don't understand dark matter, its behavior is astonishingly consistent. It doesn't flicker or waver, it holds everything steady. Across billions of years, through countless mergers and collisions, the same invisible framework remains intact. The universe may expand, but its skeleton endures. Scientists sometimes describe dark matter halos as the cradles of galaxies. They formed, first clumping together under gravity before ordinary matter could cool and form stars. Without those halos, there would be no Milky Way, no sun, no you. You're sitting in the aftermath of an invisible architecture that began taking shape long before light existed. It's humbling and oddly comforting to know that most of the universe's mass hides beyond your senses. What you see in the night sky, the glowing stars, the swirling nebulae is just the garnish. The real structure is invisible, silent, dependable. The cosmos is built on mystery, and that mystery behaves perfectly. Scientists still build detectors deep underground and inside mountain caverns waiting for a stray particle of dark matter to collide with an atom. So far, they've heard only silence. But even silence is an answer. It tells us the universe doesn't always need to explain itself. Some mysteries are meant to remain gentle background hums. If dark matter does turn out to be made of particles, then every second trillions of them are passing through. You ghosts streaming unnoticed through your skin, your room, your planet. They don't harm or interact. They simply remind you that you live inside something vast where visibility is optional, but order is absolute. You might think of dark matter as the invisible ink of the cosmos. It draws the outlines, defines the shapes, and lets the rest of the universe fill itself in. Expansion gives it room. Gravity gives it purpose. Together they weave the tapestry of structure you can see tonight. And perhaps that's the most relaxing truth of all. The unknown isn't chaotic, it's reliable. Even what we don't understand still keeps its rhythm, still obeys the cosmic balance that allows galaxies to spin, stars to shine, and you to rest beneath their light. So as you close your eyes, imagine those invisible filaments stretching quietly through space. They're older than light, older than dust, and still holding the universe steady while everything else drifts. You don't have to see them to trust them. The unseen is already doing its work. Now that you've floated through dark matter's quiet web, imagine another stranger partner in the expansion story, one that isn't holding the universe together, but gently pulling it apart. You've heard its name already, dark energy. It's the most dominant ingredient in the cosmos, making up about 70% of everything yet. It's the one thing we understand least. Dark energy isn't energy in the everyday sense. You can't bottle it or burn it. It's more like an inherent property of space itself, a subtle pressure that builds the more space there is. Every cubic meter of the universe seems to carry the same faint push, and as space expands, the total push grows stronger. It's as though the universe's emptiness has a personality. It doesn't like to sit still. The discovery came in 1998 almost by accident. Two teams of astronomers were measuring how fast distant supernovae were receding to determine whether expansion was slowing down under gravity's pull. Instead, they found the opposite. The universe was accelerating. It was as if someone had taken their cosmic foot off the brake and onto a silent gas pedal. The data shocked everyone. For nearly a century, scientists assumed that expansion would gradually decelerate, perhaps even reverse one day. Instead, it was speeding up, and no one knew why. Einstein himself had once introduced a term into his equations called the cosmological constant, to keep the universe static, only to abandon it, later calling it his biggest blunder. Now, decades after his death, that constant was back no longer a mistake, but a revelation. Scientists still argue over what dark energy really is. The simplest explanation is that it is Einstein's cosmological constant, a uniform, unchanging energy density pervading all space. But other theories say it could be a dynamic field quintessence that changes over time, perhaps oscillating or fading. Some even speculate that what we see as acceleration might arise from subtle distortions in space-time itself, effects we don't yet understand. Whatever it is, dark energy governs the future. Because of it, galaxies beyond a certain distance are already lost to us forever, their light stretched beyond reach, their existence receding faster than we can ever chase. Each second, more of the universe slips past that horizon. It's a melancholy fact, but also a gentle one. Expansion isn't destroying anything. It's simply widening the distance between everything that has ever loved everything else. You could think of dark energy as the softest kind of separation, an expanding silence between notes in a song that never quite ends. The music doesn't stop. It just slows until every sound becomes space itself. Here's the irony: for all its cosmic dominance, dark energy barely affects your daily life. Inside galaxies, gravity reigns. Inside rooms, electromagnetism rules. You could spend 1 million lifetimes without feeling the slightest tug from dark energy, and yet it shapes the destiny of everything you'll ever know. The big things, the galaxy clusters, the visible universe follow its lead. In the long run, if dark energy remains constant, the expansion will keep accelerating. Galaxies will drift apart, stars will fade from view, and eventually only our local group, Milky Way, and its neighbours will remain visible. The universe won't end with a bang or a crunch, but with a slow fading of light like theatre curtains closing in extreme slow motion. And yet that doesn't feel tragic. It feels like peace. The same expansion that isolates galaxies also guarantees stability. No collapse, no sudden annihilation, just space stretching into serenity. Every atom keeps its dignity. Every photon keeps its journey. The universe's last act is not chaos, but composure. Even the mystery of dark energy has a calming rhythm to it. For all our equations and instruments, we can't detect it directly. We only know it's there because of how galaxies move and how the cosmic background stretches. It's like hearing the wind by watching leaves rustle. The force itself remains unseen, but its pattern is unmistakable. Scientists are building new observatories to chase that pattern. The Euclid satellite launched by the European Space Agency and NASA's Nancy Grace Roman telescope are both designed to map billions of galaxies, tracing exactly how expansion has changed over cosmic time. The hope is that by measuring the history of that acceleration, we'll glimpse dark energy's true nature, whether it's constant changing or something stranger still. But even if we never fully solve it, dark energy reminds us of a deeper truth that the universe doesn't owe us understanding. It just keeps unfolding gently indifferent, yet exquisitely precise. The unknown isn't a flaw, it's part of the design. The cosmos leaves gaps in the story because mystery itself is fertile ground for awe. And in that way, dark energy is a teacher. It shows us that the most powerful forces can also be the quietest, that the vastest motions can happen without sound or struggle. Expansion continues not because it must, but because it can. The universe keeps growing the way a breath keeps flowing, not for purpose, but for balance. So tonight, let dark energy be your metaphor for rest. You don't have to control everything or even understand it. Just allow space to expand between your thoughts. Let gravity take care of what's close, and let the rest drift away at its natural pace. The universe is still growing. You can too. Somewhere between dark energy's push and gravity's pull lies the human instinct to ask why. Why does the universe expand at all? Why did it begin this way and not another? Those questions have echoed through every culture that's ever looked up at the stars, and while physics gives you the how, the deeper why remains a place where science and wonder overlap, a quiet conversation that never ends. The simplest answer is that the universe expands because it can. Once space came into being, it had no reason to stay small. Like a breath held too long, it released itself. In that first moment of inflation, there were no galaxies, no atoms, not even light, just a field of pure potential swelling faster than comprehension. Expansion is baked into the fabric of space-time. It's what space-time does when it's left to itself. But there's a subtler layer to that story. Expansion didn't just happen, it allowed everything else to happen. If the universe had stayed compact, it would have been too hot and dense for matter to form. By stretching it cooled. By cooling it gave birth to structure. Stars, planets, and life are the side effects of the cosmos catching its breath. Every heartbeat, every ocean wave, every thought you've ever had is possible only because the universe decided not to hold still. Scientists still debate what decided means in this context. Some propose that quantum uncertainty triggered the expansion, a random fluctuation that inflated into everything. Others suggest that expansion is inevitable, a built-in property of existence, like a seed that can't help but sprout. And still others think our universe is one bubble among countless others, a byproduct of eternal inflation, an endless series of beginnings that require no external cause. But you don't need to solve that riddle to appreciate its poetry. The fact that expansion continues means creation continues. Every second new space comes into being. The cosmos is still making room not just for matter and energy, but for meaning. Every moment is a small new patch of existence that didn't exist before. You're literally surrounded by freshly minted reality. If that sounds abstract, imagine this. The distance between galaxies grows by about 70 kilometers per second per megaparsec. That means for every 3.26 million light-years of distance, the universe adds 70 kilometers of space each second. It's a small rate locally, but colossal across cosmic scales. By the time you've taken a deep breath, galaxies billions of light-years away have drifted hundreds of kilometers farther apart. Space is constantly unfolding quietly, invisibly, like fabric being spun beneath everything. And yet you don't feel a thing. Expansion doesn't tug on you or stretch your atoms, because it acts only on the vastness between clusters of galaxies, within the small gravity winds. You're anchored here, perfectly safe on your little patch of space-time. The universe expands around you, not against you. That's the most soothing part of the story. You don't need to keep pace. You can rest while the universe grows. It's doing the moving for you. You're not being left behind, you're being carried. Physicists sometimes talk about the metric expansion of space, the way distances between fixed points increase, without the objects themselves moving through space. It's not like galaxies flying apart into a void, it's the void itself growing between them. It's the most passive form of motion, imaginable motion without effort. If there's a cosmic version of tranquility, this is it. That same metric defines your life on smaller scales too. Between thoughts, there's expansion. Between breaths, space opens. Between one heartbeat and the next, a moment of stillness. The rhythm of the universe is the rhythm of calm intervals, motion balanced by pause. Scientists still wrestle with the idea that this vast, elegant process could have arisen from randomness. Why something, rather than nothing, remains the ultimate question. But perhaps nothing was never truly empty. Even in the deepest vacuum, quantum fields hum. Maybe the universe didn't come from nothing, it came through nothing, emerging from a sea of potential that was always ready to expand. The philosopher's version of that idea is simple: existence prefers existence. Once there was the possibility of being became unavoidable. Expansion is the natural consequence of that preference. A universe that can exist will. There's a certain peace in accepting that answer, however incomplete. The universe doesn't need a grand reason to expand any more than you need a reason to breathe. It's an expression of what it is, not a goal it's reaching for. In that way, it mirrors life itself, continuous motion, not toward something, but within something. So tonight, as you lie still, you can think of expansion not as a distant phenomenon, but as the deepest truth of all things. Your thoughts expand, your lungs expand, even your atoms vibrate with miniature versions of cosmic rhythm. The same equations that describe galaxy stretching describe the energy between the particles in your body. You're made of space-time in motion. Maybe that's why the universe feels so peaceful when you stop to notice it. It isn't in a hurry. It doesn't need a finish line, it simply keeps unfolding one moment at a time in perfect patience. Expansion isn't a race, it's the universe learning how to rest while moving forever forward. You're starting to feel it now, the quiet confidence of a universe that never stops growing. The more you think about expansion, the more it feels like a language, one that everything in existence speaks whether it knows it or not. Galaxies speak it through drift stars, through fusion U, through breath. And underneath all that motion, there's something even subtler. The realization that expansion isn't just happening around you, it's happening within you. Take a moment to think about your atoms. They're mostly empty space. The nucleus made of protons and neutrons is absurdly tiny compared to the orbiting cloud of electrons that define an atom's size. If the nucleus were the size of a pea, the nearest electron would be 100 meters away. Everything solid around you, your hands, the walls, the air is built from emptiness held in place by invisible forces. That emptiness is not static. It's alive with motion, the same restless hum that pervades the cosmos. Expansion at the larger scale mirrors the restless vibration at the smallest. You're a microcosm of the same process that stretches galaxies apart. Between your atoms, between your molecules, the same fabric of space-time quietly continues its work. Scientists sometimes remind us that the distance between particles doesn't increase the way the space between galaxies does, because forces like electromagnetism overpower the pull of expansion. But still, the analogy holds. The same geometry, the same laws, the same tendency to move outward exist everywhere, from the scale of subatomic fields to the scale of the cosmic web. Expansion is the common denominator of everything that exists. It's humbling to realize that the emptiness inside you is made of the same kind of space that fills the universe. The void between your atoms and the void between galaxies are not different kinds of nothing, they're the same kind of something. They both hum, with dark energy bathe in cosmic microwave background radiation, and curve subtly in response to gravity. The space inside you participates in the same expansion that carries Andromeda and the Milky Way toward each other, and then beyond. That means you aren't in the universe. You are the universe. Every part of you belongs to the same continuum. You're not floating through space, you're composed of it. The hydrogen in your blood was born in the Big Bang. The carbon in your cells, forged in stars, the calcium in your bones, made in the last breaths of dying giants. You're not a visitor to the cosmos. You're one of its local expressions, a temporary arrangement of energy made possible by 13.8 billion years of expansion. Scientists still debate what nothing even means. Is empty space truly empty, or is it an ocean of energy endlessly fluctuating? Quantum theory says the latter, that even the most perfect vacuum teems with temporary particles popping in and out of existence. That means there is no such thing as nothing. The space inside you is a quantum sea, just as alive as the space between galaxies. The ancient philosophers had their own version of this insight. As above, so below, they said the structure of the heavens reflected in the smallest grain of dust. They couldn't have known how literally true that would turn out to be. The geometry of space-time that determines how galaxies form also governs the behavior of atoms and molecules. The same mathematical curves describe the fall of an apple and the orbit of entire clusters of galaxies. In that sense, the universe doesn't scale, it repeats. It's fractal, echoing itself at every level. You too are part of that echo. The way your lungs expand mirrors the way space expands. The way neurons connect resembles the cosmic web. The flow of blood through your veins follows the same branching mathematics that rivers and galaxies share. It's not a metaphor, it's pattern. You can almost feel it, the smallness of yourself dissolving into something vast. You're not separate from the expansion, you're an instance of it slowed down and made conscious. When you breathe the air around, you move softly, but on a deeper level, the very space in which you exist is stretching, carrying every particle a fraction of a fraction farther apart. It's imperceptible, but real. So when you exhale, imagine that you're participating in the same motion that began with the Big Bang, that your breath is the continuation of an ancient expansion still unfolding. The carbon dioxide leaving your lungs joins the air, joins the atmosphere, joins the current of molecules that move outward, endlessly recycled by the planet, the stars, and the cosmos itself. Scientists often say that energy can't be created or destroyed, it only changes form. Expansion is the universe's most elegant example of that truth. The potential energy of the early universe didn't vanish. It transformed into motion, structure, and time itself. Even your thoughts tonight are small eddies in that same flow. You can take comfort in that continuity. The expansion connects everything, stars and cells, atoms and ideas. It reminds you that distance doesn't mean separation. The farther galaxies move apart, the more they prove they began together. Every widening is also a memory of unity. So as you rest, let that thought dissolve into calm. The same vacuum that stretches between the stars hums within you too. You're made of the universe's curiosity, built from its expansion, sustained by its rhythm. There's no real boundary between your inner stillness and the outer infinite. Both are the same field, breathing, expanding at peace. You felt the universe outside you and within you, and now you begin to sense how those two truths meet in time. Expansion isn't just about distance, it's about duration. Every stretch of space also stretches the rhythm of time itself. The faster the universe expands, the slower its heartbeat seems to become. And that slowing is what gives existence its melody, a long, patient unfolding, never hurried, never late. When scientists describe the expanding universe, they don't picture a clock ticking somewhere above it. Time isn't separate from space, it's woven into the same fabric. The term space-time isn't just poetic. It's literal. As space expands, time flows differently through it, stretching like the light that travels within it. In the same way you can't talk about the shape of the sea without also talking about its tides, you can't talk about expansion without time. At the beginning, when the universe was dense and hot, time moved fast, at least it would seem that way to us now. The first few seconds after the Big Bang were a blur of creation quarks binding into protons, photons decoupling from matter elements being born. Then, expansion began to cool the chaos and time stretched. The tempo slowed. Galaxies took billions of years to form. The universe exhaled into a slower song. The further we look into space, the further back we look in time. Distant galaxies are not just far away, they're young. Their light began its journey when the universe itself was still a child. Expansion means we live in a cosmos that shows us its own past every night. The sky's a time machine. Every star is an old photograph, its light stretched by the same expansion that carries you through your days. Scientists still argue about the nature of cosmic time. Is it absolute ticking, the same everywhere, or local bending and stretching according to gravity and motion? Einstein's equations suggest the latter. There is no single universal now. Every point in space-time has its own clock, and expansion means those clocks drift apart. Somewhere in a distant galaxy, the same moment you call tonight might correspond to an era before Earth even formed. Time isn't a river flowing past you, it's a vast landscape, and expansion is how you move through it. That realization can be strangely calming. The universe isn't racing away from you, it's simply revealing different layers of itself at different tempos. You're not late or early, you're precisely synchronized with your patch of space-time. The light reaching you now from a galaxy 10 billion light-years away left before your species existed, yet it arrives in perfect harmony with your breath. The universe's timing, though incomprehensible, is flawless. Some physicists describe this vast coordination with the concept of the block universe, the idea that all moments exist simultaneously laid out like pages in a book. The past isn't gone, and the future isn't waiting. They're all there side by side, written into space-time. Expansion in that view is just the process of flipping through the pages one instant after another. You never leave the story, you simply move through it. That idea may sound abstract, but it has a quiet emotional weight. If all time exists, then nothing truly disappears. Every laugh, every heartbeat, every orbit of the moon still exists preserved in the geometry of space-time. You're not fleeting. You're a line through eternity, stretched by expansion but never erased. And because expansion also stretches time, the future has more room than you think. Even as entropy rises and stars fade, time continues to open, giving the universe infinite patience to try new things. There's no hurry to resolve its mysteries, no deadline for discovery. Every new second is fresh space to exist in. When you look at the night sky, you're seeing light that has aged for billions of years, and yet when it enters your eye, it becomes now. Expansion doesn't just carry light through space, it carries the past into the present. Every photon is a courier bringing a message from another time I was, and therefore you are. You can think of your own life the same way. Your memories are red-shifted photons of experience stretched by the years, softened, faded into warmth. They don't vanish, they expand. The further you drift from them, the gentler their light becomes. Time turns everything into background radiation, eventually a glow of continuity instead of sharpness. Scientists sometimes call this temporal stretch the cosmic time dilation effect. The same phenomenon that makes distant supernovae appear to explode in slow motion ensures that the universe as it expands experiences its own version of mindfulness. Each event lasts a little longer, seen through the lens of growing space. The larger the cosmos becomes, the slower its heartbeat. The pace of existence itself mellows. There's peace in that thought. The universe isn't running out of time, it's making more of it. Every instant of expansion increases the total amount of possible moments. Time doesn't fade, it multiplies. So when you lie there listening to your own slow breathing, remember that you are perfectly in tune with the universe's tempo. The cosmos has been decelerating into calm for billions of years, and you're part of that deceleration. You're in a very real way the still point in an expanding song, a brief note, yes, but one carried endlessly forward by the rhythm of time itself. Now the tempo of the universe feels familiar, slow, steady, patient. You've travelled from the quantum foam to galaxies and back again, and you begin to sense something profound. Expansion is not just a property of the cosmos, it's the story of how everything learns to change without breaking. The stars, the atoms, even you all are practicing the same art of becoming. Everywhere you look, the universe demonstrates it. Nebulae expand into stars, stars swell into giants, supernovae scatter into dust, and that dust gathers again into new suns and planets. Even galaxies collide and merge their stars, mixing like rivers joining the same sea. Expansion makes room for these transformations. Without it, everything would remain trapped in the first instant, locked in a single moment of brightness and chaos. The universe grows because that's the only way it can evolve. Scientists sometimes call this ongoing process cosmic evolution, and it's not a metaphor, it's literal physics. Expansion changes density, density changes gravity, gravity changes temperature, and temperature decides what matter can become. Each step in that chain leads to new complexity. The universe expands and chemistry is born. Chemistry expands and biology follows. Life in the broadest sense is expansion made self-aware. That awareness is what you feel when you look at the night sky, and feel both small and infinite at once. It's not humility, it's resonance. The same laws that govern galaxies are whispering through your bloodstream. The same atoms that forge the stars are holding hands inside your DNA. You are what happens when the universe expands long enough for matter to start wondering where it came from. Scientists still debate whether consciousness has any cosmic role. Some argue it's just an accident, a byproduct of chemistry. Others propose that awareness might be an inevitable result of complexity, a kind of universal echo. Whatever the answer, it doesn't change the fact that you're here perceiving an expanding universe from inside it. The observer and the observed are the same fabric folded back on itself, like space-time curving to look in a mirror. And when you zoom out far enough, that connection becomes beautifully literal. The heavy elements in your body, carbon, oxygen, iron, were made inside stars that lived and died billions of years before the sun existed. Every breath you take contains molecules that have travelled through clouds of interstellar gas across light years, through comets, oceans, and lungs before reaching you. Expansion didn't just carry galaxies apart, it carried the ingredients for life across unimaginable distances so that one day they could recombine as thought. In a sense, expansion is the great recycler. It takes energy, spreads it thin, and gives it time to reorganize. It's the opposite of confinement. When space grows, possibilities multiply. The same principle works in your own life when you create space between moments. Between thoughts, new understanding appears. The universe models mindfulness better than any philosophy. It knows that peace comes from giving everything room to breathe. Scientists use the term cosmic horizon for the limit of what we can see, but you have a smaller version of that horizon inside you. Beyond it lie the parts of yourself you haven't met yet. Ideas waiting to form, emotions waiting to be named, hopes waiting to stretch into tomorrow. Just as the universe keeps making new space, you keep making new self. Expansion never stops, even in the quiet of your mind. You can test this every time you take a deep breath. The air filling your lungs isn't static, it's the same air that once brushed the surface of ancient oceans, the same molecules that once drifted through volcano plumes or forest leaves. The oxygen in your blood right now was born in a star that exploded before the Earth existed. Every inhale is a tiny reunion across cosmic time. Expansion allows that reunion to happen endlessly. Sometimes when scientists model the universe on computers, they describe the result as a cosmic sponge, dense threads of galaxies connected across vast expanding voids. It looks oddly familiar, almost biological, like neurons or capillaries. The shape of everything large mimics the shape of everything alive. Perhaps that's not coincidence. Perhaps the universe's expansion is a kind of learning process, a way of exploring every possible configuration of existence. If that's true, then you're part of that exploration. You are the universe, thinking, dreaming, and resting between pulses of growth. Expansion doesn't just happen out there. It happens when you learn something new, when you forgive, when you let an old fear drift away. The same physics that lets galaxies move apart also lets you move beyond what you once were. Scientists sometimes reduce the beauty of this to equations: entropy increases, energy disperses, systems seek equilibrium. But between the numbers hides something more human grace. The universe doesn't fight its expansion. It doesn't cling to its first form. It accepts change as the path to continuation. You can do the same. Every heartbeat you feel is a small expansion, followed by contraction, a microcosm of cosmic rhythm. Every night's sleep is a personal version of heat death, the world cooling, reorganizing, preparing for renewal. The grandest truths of physics play out in the softest corners of your life. So when you think about the universe expanding, don't imagine emptiness growing. Imagine possibility unfolding. Imagine room being made for new stories, new beings, new light. The cosmos isn't leaving you behind. It's making space for you to exist. You're one of its reasons for stretching. And as you lie there breathing in time with galaxies, you realize something deeply calming. Expansion isn't about distance at all. It's about continuity. It's the universe's way of saying that nothing ever really stops. It just transforms, drifts, and finds new forms of meaning. The same applies to you. You're not standing still, you're quietly expanding too. By now you've followed expansion from its fiery birth to its quiet horizons, from the stretch of galaxies to the space between your own atoms. There's only one step left to rest in the understanding that all of this motion, all of this widening has been leading not to noise or chaos but to harmony. The universe expands, and in doing so it learns how to be calm. If you look around your life, you can see the same principle playing out in miniature. Cities spread outward, families grow rivers, carve new paths, and yet beneath all that change there's an underlying rhythm of balance. Expansion doesn't always mean rushing forward. Sometimes it's just a gentle settling, a making of room for what already exists. The cosmos itself is doing that right now, billions of light years wide, creating more space not to scatter its contents, but to let them breathe. The galaxies will keep drifting apart, the stars will keep cooling, and space will keep stretching. But none of that should feel lonely. Expansion is simply the universe's way of ensuring that everything has its own place. Imagine the opposite, a cosmos that never grew, where everything stayed cramped and colliding. It would burn itself out instantly. Growth is what keeps it alive. Growth is what keeps you alive. Even the most advanced telescopes can't find an edge or a center to the universe. The expansion happens equally everywhere, and that means every point, including the one you occupy, is special. You are the center of your own observable universe, not metaphorically, but literally. Light from all directions meets in you. The story of expansion is written into every photon that enters your eyes, every breath that fills your lungs, every heartbeat, syncing with the rhythm of cosmic time. Scientists still refine the numbers, measuring the Hubble constant, debating whether the universe is expanding slightly faster or slower than we think. The argument has become known as the Hubble tension, and though the data differ, the underlying message is steady: expansion continues. It's a rare kind of disagreement, one that doesn't threaten the harmony of the whole. Even in uncertainty, the cosmos remains consistent, and maybe that's the real lesson. The universe doesn't need absolute answers to keep moving. It doesn't stop to double-check its math. It grows through imperfection, through the gentle tug of war between what is known and what is still unknown. You too can afford that freedom. You can expand without fully understanding how. You can evolve without having a final plan. In the end, expansion isn't a race towards something. It's a conversation between energy and space possibility and patience. It's what allows the future to exist at all. Every moment you live is a new pocket of space-time forming around you, a small but genuine act of creation. You're not watching the universe expand, you're participating in it. Think about the atoms in your body. They were once hydrogen nuclei drifting in the early universe, pushed apart by expansion, drawn together by gravity, fused inside stars scattered by explosions, and eventually assembled here. The same expansion that flings galaxies apart once helped gather the ingredients that make you whole. It's not chaos, it's choreography. It's not emptiness, it's generosity. And so, as you breathe, imagine the air around you as part of that grand unhurried flow. Every molecule in your lungs has been part of a star, a cloud, a comet, a tree. They've traveled through expanding space for billions of years just to be here in this exact moment, joining your breath. You are their resting place, their brief pause in the endless drift outward. The most relaxing fact of all is this: the universe isn't expanding into nothing, it's expanding into itself. There is no boundary, no outside, no final destination. It's an endless unfolding, and you are inside it at home in infinity. That means you're safe. There's nowhere to fall off, nowhere to disappear, to nowhere you aren't already part of. If you listen closely enough, you can almost hear it, the faint hum of cosmic background radiation, the whisper of distant galaxies moving, the soundless breath of space growing softer with time. It isn't rushing, it's sighing. The universe has been exhaling for 13.8 billion years, and you're hearing the quiet end of that breath. And maybe that's the point, to live inside an expansion that teaches you patience. To know that everything you see, everything you are is temporary but continuous. The galaxies drift, but they're never truly lost. Their light still travels, their gravity still sings, their matter still finds new shapes. Nothing vanishes, it only relaxes into another form. You are part of that relaxation. You are a ripple in the universe's infinite exhale, one more wave in the long, slow tide of creation. There's nothing you need to do, nothing to fix, nothing to hold on to. You can simply rest knowing that the expansion carries you too. So as your thoughts slow, as your breath falls into rhythm with that grand cosmic drift, remember, the universe doesn't rush, and neither should you. It's still expanding, still becoming, still serene, and tonight, so are you. The story quiets now, but the expansion continues softly, endlessly, beneath everything. The galaxies keep their distance, the light keeps stretching, and the silence between stars grows more peaceful by the second. Somewhere out there, photons that left their homes billions of years ago are still traveling, still carrying their messages of warmth and memory through the deep. None of them are in a hurry. That's the secret the universe has been whispering all along. You don't have to rush to become complete. Even the stars, those blazing symbols of energy and power, live slow lives measured in patience, not in haste. Their fusion burns gently, not urgently. Their light takes its time to arrive, and when it reaches you, it does so with grace. If you could float among them now, the view would be almost silent. No explosions, no drama, just quiet light crossing infinite space. Expansion smooths everything. Time lengthens every motion until it becomes tranquil. You can feel that same smoothing happening inside you. The slowing of thoughts, the lengthening of breaths, the widening of calm between each heartbeat. You've been part of this story since before you were born. The atoms that make your body were carried here by the same expansion that still shapes galaxies. You're in the truest sense recycled starlight energy that once travelled at impossible speeds, now resting as warmth beneath your skin. Every exhale you release adds a tiny breath to the universe's own one that has been flowing outward for almost 14 billion years. And yet, despite its immensity, the universe has never stopped making room for small things, for stars, for planets, for fragile lives that last only moments compared to its vast age. It keeps creating space for you too, for your thoughts, your memories, your quiet dreams. You exist because the universe made room for awareness. That might be the most comforting truth of all. So as the night deepens, imagine the galaxies still gliding away, their motion so slow it feels like stillness. Picture the cosmic microwave background like a faint warm blanket wrapping all of existence. Let that thought wrap you too. You are surrounded by the same calm part of the same balance. You don't need to think about tomorrow or about the edges of the cosmos. Tonight there are no edges, only the soft continuity of everything breathing quietly in time with your own. Expansion goes on without effort, and so can you. Let your thoughts fade like starlight redshifting into the dark. Let your body feel lighter, as if gravity itself has loosened its grip. The same peace that fills the universe fills you. The universe expands, but it never leaves you behind. It carries you with it gently, endlessly into rest. Sweet dreams. Sweet